All right, 3 quick announcements before we start. Number 1, we're starting the 100x devs cohort 3.0 tomorrow. If you want to learn web development, DevOps or Web3, you can enroll in the cohort. It will be very beginner friendly in the classes. So the classes are going to be slow. At the same time, we're going to amp up the pace on projects. So we'll be having a bunch of open source projects that will have specific maintainers. If you want to go aggressive, you should participate in the projects. If you want to learn slowly, you should come to live classes. The first class, the Web3 orientation, is going to happen tomorrow on 2nd of August. I hope to see a few of you there. Number 2, we're sponsoring a bounty with Super Team to bring more developers onto Solana. So if you're part of the cohort, this is exclusively for the people in the 3rd cohort. You can participate in the hackathon. The hackathon starts today. You have to build projects very similar to the one that we're building in this video. The deadline is end of month. You can create teams of 2. The top 50 teams will win $100 each. If there aren't enough submissions, then you win more money. The bounty pool is of $5,000. So if only 5 teams give the best submissions, we'll be distributing $1,000 with each one of them. If 50 teams give the best submissions, then of course we'll be distributing $100 per team. It's exclusively for the cohort. I'll be sharing more details in the orientation session tomorrow. Number 3, this video is going to talk a bit about crypto licensing, how to build a centralized exchange, specifically India specific challenges. If you are a small crypto exchange in India, or if you are a lawyer who understands crypto licensing, I would love to get in touch just for some personal reasons. So let me know in the comments or mail to me at 100xdevs@gmail.com. Just a bat signal to send out if someone is in this space. Without any further ado, we're going to look at a cohort intro video now, then we'll get into the main video.
Hey guys, and welcome to another video. In this
auto चलाते बाबा यहाँ पे ਟਾਈਮ ਲੱਗੂ ਮਿਟਣੇ ਨੂੰ ਸਾਨੂੰ ਥਲੇ ਸਿੱਟਣੇ ਨੂੰ 21 ਵਾਰੀ ਜ਼ੋਰ ਲਾ ਲੈ 36 ਬਲ ਕੱਢ ਤਾਰ ਕਾਨੇ ਹੁਣ ਟੁੱਟੇ ਨਾ ਕਰੀਜ ਹੌੜਾ ਰੁੱਖਿਆ ਸਵਾ ਦੇ ਸਾਨੂੰ ਆਉਂਦੀ ਨੀ ਤਮੀਜ਼ ਆ ਲੈ ਤੈਨੂੰ ਦਿੱਤੀ ਸਾਂਭਲਾ ਨੀ ਬੇਬੇ ਵਾਲੀ ਚੁੰਨੀ ਬੈਠਾ ਡਬਲਾਰ ਵਿੱਚ ਪਾ ਕੇ ਬਾਪੂ ਦੀ ਕਮੀਜ਼ ਤਾਂ ਰੁਕ ਜਾ ਦਿਮਾਗ ਸਾਲਾ ਰੁਕਦਾ ਨੀ ਮੇਰਾ ਤਾਂ ਹੀ ਲਾ ਲਈਏ ਸਮਾਧੀ ਮੈਡੀਟੇਸ਼ਨ ਆਰ ਕਾਨੇ ਲੋਕੀ ਸਾਡੇ ਕੋਲੋਂ ਸਿੱਖੋ ਹੁਣ ਸਾਨੂੰ ਦੇਣ ਮੱਤਾਂ ਸਾਨੂੰ ਕਿੰਨਾ ਕੁਝ ਦੇ ਗਈਆਂ ਨੀ ਮਿੱਟੀ ਦੀਆਂ ਬੱਟਾਂ ਹੋ ਲੰਗੇ ਤੇਰਾ ਯਾਰ ਮਾਰ ਕੈਮਰਾ ਫਲੈਸ਼.
Alright, let me set the context for the video. This video is going to be divided into 2 parts. Part 1 is me taking you through how can you build a centralized exchange in India, what are the challenges when it comes to regulations, what are the security related challenges, how can you try and make sure you're not getting hacked, what might have gotten wrong with WazirX or FTX. We'll understand all the jargon needed to build an exchange. Part 2 is going to be us building a slightly different type of a centralized exchange. It will be a combination of a decentralized and a centralized exchange. It will more specifically or technically be wallet as a service. It will be a platform where you can come, sign up, and once you do, you have a wallet created for you. You can on-ramp crypto over here. In the future, if you have banking rails, you should also be able to add INR. Let the user swap one token for another and maintain a wallet balance very similar to a centralized exchange. That said, it's different from a centralized exchange in the sense that every user owns a wallet separately. There is no single parent wallet that holds all the user funds. Without any further ado, let's get right into the video. Alright, hi everyone. This video is going to be divided into 10 parts, I think right now. I'll take you through the architecture of building a centralized exchange. Then we'll understand what exactly went wrong with WazirX. If you're building an exchange, what are the things that you need to keep in mind? You need to be overly cautious about. These are things that should, give you sleepless nights. And what exactly went wrong in WazirX, what exactly went on in FTX. How will we try to avoid both of these things in our exchange that we'll try to build? Some jargon if you're trying to build an exchange. Specifically, we'll understand what are multisigs, which is something that WazirX used. A lot of exchanges don't use multisigs. There are other ways to do something similar. Today we'll be using a multisig, but in a slightly more secure fashion. Decentralized exchanges, you might ask, why do you need a decentralized exchange if you're trying to build a centralized exchange? And I'll come to why that is. Market makers and what is spot in the context of a centralized exchange. India specific challenges. Building an exchange is very different from building an exchange in India. Specifically, you have to have a crypto tax every time you're swapping. That's probably the easy bit. Withdrawals are tricky. You can't let users withdraw Ethereum or withdraw Solana. Users can only on-ramp using INR. Users can only off-ramp using INR. In India, you're allowed to buy crypto, but you can buy crypto using your Indian rupee, and you can always just sell it for Indian rupee. You can't pull it out of the centralized exchange. That's just a regulation that we have. INR USDT, what is this specific market? Why is this so important when it comes to the context of an exchange? Why, irrespective of if you're building a decentralized exchange or a centralized exchange, in India, you need, INR USDT market somehow sorted out. Licensing in India, if you want to build an exchange, if you've built this app you're building today, what's the next steps if you want to, create your own exchange, let's say, and banking APIs, which is something you will only get if you have an FIU license. Architecture of what we're trying to build today. So what we're building today is a SEX. It's a centralized exchange, very similar to WazirX, Coin DCEX, but it has some architectural differences, which is why I've named it as DCEX, centralized exchange. I'll talk through why that is, what that is, and why I've built it this way compared to how most SEXs are built. If you're interested in understanding just how a centralized exchange is built, then you should probably go to this video of mine where I've discussed the same thing. We are trying a different architecture today for security purposes, and also because it's very hard to get market makers in India. And if you're making something like this, then it's easier for you to bootstrap your platform. Building the front end for it. Okay, this up until this point is going to be a lot of discussions. From 6th point onwards, we'll actually start to code it. I've broken it down into various, small things you have to do. The first thing is building the front end really quickly, like a sign up page and a balances page and a swap page. Sign up, sign in logic, just writing, a very basic backend. Then we'll add some multisig initiation. So you'll understand what multisigs are here. Here, I will actually start to show you how you can create your own multisig on, let's say, Solana, Ethereum, whatever blockchain you're trying to integrate on your centralized exchange. Mocking on-ramps. So we don't have any banking APIs. We're not an exchange yet, which is why we will have to mock a bunch of, putting INR into the bank account or into the platform. You can use Razorpay, you can use Stripe, but you cannot, because Razorpay and Stripe will ask you what is your business, and you cannot select crypto exchange as a business. So you can't integrate with these payment providers. You have to integrate directly with the bank. You can only do that if you have an FIU license. So we'll be mocking this out. If you build this out into an exchange, you have the right licenses, then sure, you can build your own on-ramps and replace this with an actual banking API. Then we'll add actual functionality for you to swap. Adding spot over here means just letting the user swap, let's say, the INR for Ethereum for INR, and we'll be sourcing liquidity from a DEX. I explain later what this means and why we're doing this. And finally, we'll discuss some attack vectors. Even our approach isn't foolproof. So I'll share where exactly are the attack vectors and how you can fix those if you want, a truly as safe as it gets centralized exchange. Without any further ado, let's get into the first part, the architecture of a centralized exchange. All right, discussing the architecture of a centralized exchange. If you're ever building something like WazirX, what do you need to do? You need to figure out two types of people. Number one, your end users, and number two, what are called market makers. Your end users is fairly simple. Some, person who wants to buy crypto in India will, number one, go to the WazirX platform. Number two, do a KYC. Number three, put some INR from their bank account on ramp onto the platform. And number four, now they can convert their 10,000 rupees into, let's say, either USDT or Ethereum. This is what happens on the user side. This is what the user sees. Which one of these seems like a challenge to you? Where do you think, things are going to get slightly harder? Is going to the WazirX platform hard? No, it's easy. Signing up a user is fairly simple. Doing a KYC for a user is also fairly simple. There are a bunch of companies. A famous one is called SumSub that lets you do KYC as a service. So you don't have to do much as the platform over here. Taking 10,000 rupees from a user's bank is also not that difficult. If you integrate directly with a bank like HDFC, SBI, people can send you 10,000 rupees and you can, debit their account, credit their account with this amount. The user can see this in their dashboard. Swap 10,000 rupees for 120 US dollars, or more specifically or more technically, this will be USDT. This is the first challenging bit. And then converting the user's $120 into 0.01 ETH is the second challenging bit. Because in both of these cases, you need something called liquidity. Liquidity is another jargon that I'm introducing here, but it basically means you need people on the other side who are willing to take the other side of this bet. If there is someone who wants to convert 10,000 rupees into 120 USDT, you need someone, and usually these people are called market makers, who is willing to sell $120 for rupees 10,000. This is the other side you need to figure out. If you're building a centralized exchange in India, one of the biggest challenges, or if you're building a centralized exchange generally, one of the biggest challenges is getting market makers. Who are market makers? As the name suggests, they make the market. They are always available to take an order. If there is a user on your platform that comes and that specific user is, wants to do this specific trade, market makers are sitting on the other side, willing to take the other side of the trade. So usually you are trading against market makers. And the exchange needs to figure this out. You can't just build an exchange and ask users to put 10,000 rupees and convert the 10,000 rupees into something. You need someone else on the other side who's willing to take the opposite end of the trade. These people are called market makers. Usually they have a lot of incentive to come on your platform. And, it's not too difficult to get market makers, but it's very hard to get market makers in India. The reason is that every transaction in India costs 1%, or you have to pay the government 1% in taxes, which is too much money for a market maker, because a market maker is trading very heavily. It eats up their working capital. Every market maker has a bunch of capital, or bunch of money. They usually have, let's say, $20,000 or $200,000. They also have 100 ETH. They have a lot of capital. They sit on something called the order book. Forget about what that is. They're basically always willing to take these trades that you see over here. But it doesn't make too much sense for them to take all of these trades if they have to give away 1% of every transaction to the government, which is why one big challenge in India is bringing on market makers. Believe it or not, I myself was about to become a market maker on WazirX. I had conversations with the team and eventually did not go through because there were too much legal jargon to go through, which I forwarded to my mother, and she did not follow through. But I was about to be one of the market makers in WazirX, because WazirX did not have a lot of liquidity. It was easy to make some money as a market maker over there. Think of it that way. So these are the two sides you need to figure out. What we are building, as I said, is not exactly a centralized exchange. We are building a DCEX, which is why we won't need too many market makers. We will need one set of market makers. I'll share what that is. But a centralized exchange needs to have both of these. Okay? Once they have both of these, once they have market makers on one side, users on the other side, the architecture of onboarding market makers and onboarding users looks something like this. All right. Let's discuss the architecture of, these two people, the users and the market makers, and how you build your backend systems so that you can allow users to trade. Firstly, you need to figure out the market makers. Users can only come on your platform if you have enough liquidity. What does liquidity mean? Basically means that you have convinced some market maker, which are usually companies like Citadel or Wintermute, Jump. These are big companies that usually do market making. You have to convince them to come to your exchange and provide liquidity. What does providing liquidity mean? Basically means something like this. If you look at this website, this is DCEX, one centralized exchange. And on the right side, you see what's called an order book. This order book clearly shows you that there are a few people who are willing to sell US dollars. They are selling, let's say, someone is willing to sell $2 for 89.16 rupees. This is the best price to buy US dollars on DCEX right now. Someone is willing to sell 1592 for USDT for 89.17 per US dollar. Usually the US dollar is around $83. But if you want to buy USDT on DCEX, the price is really bad. You have to give 89.16 at the very least. This is the best price of US dollars or USDT more specifically on this platform. And then there is the other side. There is someone who's saying, okay, bhai, I want to buy. I really want to buy, but I will only pay 88.82 rupees. So these two sides are what are called, two sides of an order book. There are a bunch of people who are here who are willing to buy, but the best buy offer, the best offer is 88.82. The best, what's called ask. The best ask is 89.17. One of these parties need to move, or a new user needs to come. For example, if I am a retail user, a simple user, I will come and place a market order. Market order means that whatever is the best price, give it to me. I can say give me 2 USDT. And as you can see, this 2 USDT gets matched to this order over here. So a user can only come, I am a normal user, I can only come and trade if there are existing market makers, people who are sitting on the order book. If no one is here, then what will your users do? Their order will not be able to be matched with someone. So first, bring a bunch of market makers. They will fill the order book like this. Of course, this is not a very liquid order book. There is a very big what's called spread. Spread means that 88.83 is the best price to someone is willing to give to buy, and 89.17 is the best price that someone is selling for. So there's almost 20 paise or 0.2% of spread over here, which is really high. It should be lower, but since this is a very illiquid market, not a lot of people trade on USDT INR, you see such a big spread. If I am a normal person, I will come here, place the market order, and I will get the best price over here. The best price unfortunately is 89.05. So if I try to buy USDT, I get it for this specific price. I eat 2 quantities from here. Let's see that one more time. If I go here, click on market, and let's say try to buy 2 quantity. Notice the quantity here is 55. Let me buy. The quantity goes down to 53 because I took away liquidity from the order book. I bought 2 USDT over here. That is the first thing you need to figure out. Getting market makers. After you've convinced these people, you need to ask them, hey, this is our crypto address. Send me, let's say 50 ETH over here and 20,000 USDT over here, let's say, and 20 Bitcoin over here. So that after you've sent me this, only then will I let you come to my platform and let you trade your assets. You've sent me 50 Ethereum. Now you can put your 50 Ethereum here so that my users can buy this 50 Ethereum. So the first thing you need to figure out is how do you convince these people and how do you take their assets then? The 240 million that is currently lost on WazirX is not all user funds. A bunch of these might be funds of these market makers, which is why I felt very fortunate that I was not a market maker there, else my funds also would have been lost. Because this 240 million isn't just people's money, it's also market makers' money. Why do market makers need to put money in there? Because if they don't put money, how can they sit on the order book? Someone needs to have 55 USDT. Only then can they say, okay, I'm willing to sell this 55 USDT for 89.05. It is like if I have a house in India, I will first need to sort of give my house to a broker, right? Okay, yaar, ye lo. This is my house. Keep it. Whenever you find a good order, right? Please sell it for 4 CR rupees or 3 CR rupees. So sitting on this order book is similar to me giving my house to a broker. Ke bhai tu rakh le, abhi ke liye. Please keep it for now. When you find a good offer, just return me the 4 CR rupees for my house. When I bought 2 USDT, the person who sold me 2 USDT got back 170 rupees in return. If I go to my funds, I now have 6 USDT. If you go to that person's fund, they will have lesser USDT, more INR, because my INR went to them. Cool. That is the first thing you need to figure out in terms of, the tech that you have to build. After you have liquidity, after you've built enough tech to take money from market makers, as well as letting them, you're allowing them to trade, you've created an order book where they can come and put their assets. You need to figure out the other side. What is the other side? The users. All right. On the user side, what happens is different in other countries, different in India. In case of India, number one, your user, signs up to the platform, and after they have signed up, they send you some INR rupees. For example, if I am on this coin DCEX platform over here, I can go to funds INR wallet and then deposit to my INR wallet. I can withdraw to my INR bank. I cannot withdraw money to my cryptocurrency address. This is just a regulation that India has. If you want to buy crypto, you buy crypto by depositing INR. If you ever want to move out of coin DCEX, you will have to withdraw INR back to your bank. You can't hold Ethereum in reality if you're trading on a centralized exchange in India. So the first thing after the user signs up is they need to put in some money, else they can't trade. So they will put, let's say, 20,000 rupees into your bank account, which is a simple thing. There are many platforms that charge money in India in INR. You go to any e-commerce website, course selling website, you pay them money, they give you something in return. You go to Paytm wallet, you can on-ramp 20,000 rupees in there. Once you have 20,000 rupees, then the user can go and start to buy the assets. So in the database that exists for WazirX, there is a plus 20,000 rupees entry over here. And whenever you go to, a UI like this one and try to buy or sell Ethereum, for example, if I, go to a different market like a BTC market, or maybe a simpler one in Ethereum market, I can go over here and click on buy ETH. When I click on buy ETH, I can select, okay, I want to buy 0.001 ETH, let's say. It tells me you can buy it for $3 or 3 USDT in this case. I can click on the buy ETH button and it will buy it. Unfortunately, the minimum order value is this much. So let me increase this to 0.002. I don't have enough money. So 0.01617. There you go. I can buy 0.0017 Ethereum for 5.56 US dollars or USDT in this case. If I click on this, it says, order has been matched. You have Ethereum now. So my portfolio now has a different value for ETH. My USDT went from $6 to 0.0365. My ETH went up to, this number. So this is just number swapping that is happening in a database. Initially, I have 20,000 rupees. I can eventually have, 19,000 rupees and 0.001 ETH. So in a centralized exchange, you just have to build systems that change balances of the users. Now, this is done in extremely secure fashion to make sure, this cannot be manipulated by some person, employee of the company. But high level, I hope you get the idea. It's very similar to, you being on a platform like Paytm and sending someone money. Here, rather than sending someone money, you swap your one currency for a different currency. Eventually, when the user, keeps on trading, let's say they convert their 20,000 rupees into 0.2 Ethereum. And then let's say the price of Ethereum goes up. Eventually, they sell their 0.2 ETH for 40,000 rupees. And finally, they send this bank into their bank account. This is the general cycle of what happens when a user comes on a centralized exchange in India and wants to trade. They will put in some INR. They will speculate on whatever asset they want. If the asset does go up, they can convert it back to INR and send it back to their bank account. There are a bunch of nuances here, which I'm not getting into, but it's not always necessary. You get the best price for INR, but let's not go there. High level, you put your money, your INR, you can pull out INR. The only key difference between an Indian exchange and an international exchange, if you go to Binance and if you're a US citizen, then you can put in US dollars and the Ethereum that you have, let's say 0.02 ETH, you can pull it out to your own wallet address. You cannot do that in India. You cannot ever go out of the coin DCEX ecosystem. You can put in INR. You eventually have to pull out INR also. You might be able to increase the value of your INR. You might be able to decrease it, but you can't pull out Ethereum. You don't actually ever own your crypto if you're trading on an Indian exchange. Cool. That's the high level of the architecture. If you want a more detailed deep dive into how these systems are built, you should check out this video of mine that I created right after the WazirX hack. Over there, I talk about these jargons. Number one, deposit address. Number two, I talk about sweeping wallets. Number three, I talk about a deposit wallet also, or deposit funder, I guess. We talk about their primary wallet that got hacked. We talk about their withdrawal wallet. So, there are a bunch of wallets in this case. But the primary wallet is the thing you need to keep very secure, is the thing that had $240 million that, got hacked eventually in case of WazirX. How did it get hacked is what we'll discuss in the next section. All right, let's discuss what went wrong with WazirX, FTX. How do exchanges usually get hacked? If you really want to understand this better, I have a video where I discuss all of these jargon. Feel free to go there. It's on the 100x Devs YouTube channel. But primarily, any of these exchanges are holding your assets for you. And usually what goes wrong is their wallet in which they're holding that asset gets stolen. Think of it this way. Let's say there is today a new platform called Real Estate US, which lets Indians buy real estate in the US. Let's imagine. So this is the USA, and there is some big chunk of land that, let's say, a company called WazirX owns, and then Indians can buy some small plots of land over there. In the end, even though you see in your dashboard that you own 0.1, maybe 10% of that land, you don't really own 10% of the land. WazirX does. And let's say in the future, someone comes and steals this land. Stealing land is a bad example, but hopefully you get the idea. You don't actually own that land. It's held by this company. And if the founders of this company go away, run away, sell this land and keep the money for themselves, you as the Indian investor are screwed. And that is exactly what happens in case of cryptocurrency exchanges as well. You only on the platform see a number. You see something like 0.1 ETH over here. It is actually held by the WazirX folks in their primary wallet, this jargon that I have written over here. If their primary wallet gets hacked, then the centralized exchange is done. This is just a number on your dashboard. It doesn't really mean anything. WazirX does not own your crypto anymore. It has been hacked and taken by someone. Hence, you also don't own this 0.1 ETH that you see on your dashboard. Question is, how do exchanges make it so that their wallet cannot be hacked? There are many exchanges out there. There is Coinbase, Binance. Why don't they get hacked? What did WazirX do wrong that led to them getting hacked? And these are all speculations because we don't actually know what happened. The team has been fairly silent, but this is how they tried at the very least to secure their primary wallet. Their primary wallet was what's called a multisig. Now I'm introducing a new jargon here called multisig, but it basically means no one could pull funds out of this unless 4 separate entities signed on a message. So think of it this way. This is, the CXO, or let's say the CTO of WazirX. This is the CMO of WazirX. This is the CEO of WazirX. And there is some fourth external party. Let's just, again, assume it to be some CXO of WazirX. This person has a password. 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 Only if all 4 of these put in their password together can, money be pulled out from here. This is safe or, sufficiently safe. Of course, if all 4 CXOs get together, they can steal user funds, but that is probably not what happened over here. What happened over here is that all 4 of them, even though they had their own passwords, most probably, again, this is all speculation here, but most probably they were all signing messages or, they were all doing this signature sharing of password on a single website, and this website's front end got hacked. There is a website that all of these CXOs were using to, sign messages using their own password. And they didn't realize the website that they were on has, some erroneous code in there. The hacker had injected some code in here. This is speculation. No one knows. I can only guess. But, this is the primary guess right now. Okay. All 4 of them did not realize, they're on the wrong website. This is some sort of a phishing attack. And they ended up signing a message that led to, the hacker being able to pull this money out to their address slowly. I have dived deeper into what happened in the video, but high level, think of it this way. Even though they tried their best to be sufficiently decentralized, they tried to make sure 4 different people need to be under attack for the funds to be pulled out. Unfortunately, all 4 of them got attacked by the same attack and, the funds were stolen. How can you prevent against this? It seems like they were doing everything right. Then how do other exchanges do it? And the answer is some exchanges do this only. And they're hopefully, not all signing on the same web page. The problem here was even though there were 4 different places in which these passwords were kept, they were all signing on a central website. So the website became the central attack vector. What's surprising / sounds slightly wrong / something the team should have taken care of was this website is fairly hackable / whoever owns this website sort of becomes the center of this attack. If this website can be manipulated, then doesn't matter how many signers you have or, how far they live and whether they know each other or not. These are the benefits of a multisig. If you distribute them with random people and, you just hope they don't know each other, so, they will never be able to get together and hack. But unfortunately, if you have a central attack vector like this, which should have been obvious to the team, all 4 of them ended up signing something and, that led to the attack happening. Question is, what could have they done better? I mean, the answer is number 1, they should all have been running code locally. They shouldn't have been going to a website like www.whatever, safewallet.com. Doesn't matter what the website is. This is a central attack vector. They should have been running some code locally that signed messages rather than going to a internet facing website that is owned by someone else. As long as they could have been sure, okay, the code that they're running, they could read through the code, they could make sure they're running, whatever process they're running. Let's say, they're running a Golang process that signs that specific message or transaction. They could have read through the code before running, go run or whatever, node index.js. They were not constantly, looking at local code. They were all accessing code from a website, which, was a central attack vector. So at the very least, what they should have done was, all four of these people should have been running this code locally. Ideally, what I've seen in exchanges is none of this code is run by humans. It's actually fairly automated. You do have various signers. In fact, we'll do the same thing today. You will have various signers, but these won't be operated by users. These will be machines in different data centers, in different cloud providers. The first machine might be in AWS. The second machine might be in GCP. The third might be in Azure. The fourth might be in DigitalOcean. Even if ever GCP is under attack, you will be fine. If AWS is under attack, you will be fine. And all the code that is running here, this is code that's running here, all local code that has been written by your own developers. And you will make sure you don't depend on an external service while doing any of this. If you're able to do this, then you can be at least, secure from attacks similar to the ones that happened on WazirX. There are still downsides here, which we will eventually discuss. But this is a better architecture. Number one, no human intervention. Number two, no central point of attack. Everyone is running their own code in different data centers. There is a dev team 1 who has access to this, dev team 2 that has access to this, 3 and 4. No single person has access to all 4 cloud providers' credentials. If there is ever a patch that needs to happen, dev team 1 will do here, 2 will do here, 3 will do here, 4 will do here. That's how you usually tend to keep exchanges safe. Now, this is different from what happened at FTX. FTX did not have a hack. FTX just had that primary wallet, and they were just, trading using this primary wallet. They were taking funds from users and, doing shady things with them. That is very different from what happened at WazirX. WazirX was hacked. FTX wasn't hacked. The founders were just, playing with users' funds, and, they played a few bad bets and ended up losing user funds. Cool. That's what went wrong here. We will be covering all of these corners in the system that we are building. At the same time, there will be some central points of attacks that I will discuss. I will also discuss how you can, fix those central points of attack if you build the system a certain way. Let's move on to the third point. All right, let's discuss some jargon before we proceed. The very first jargon is multisigs. I talked a bit about this in the last section. Usually when you own your own crypto, right? If you're not using a centralized exchange, if you actually have a private key for your wallet, for example, if I open a wallet over here of mine, Phantom is just a popular wallet. If you don't understand this, this is fine, but it just shows you that I have some Ethereum, 0.00014 ETH, which amounts to around $0.46 based on the current price of the ETH. I own this in my own wallet. I have the private key of this. If I want, I can send this over to, someone else. I can select their Ethereum address, select the amount that I want to send. Let's say it's this much. Click on next, click on send. The Ethereum will go to them. This requires a single signature. This is not a multi-sig. This is a single signature wallet. I have a wallet. There is a private key associated with the wallet. My private key is also in this application called Phantom, which is why I can take this Ethereum and send it to someone. Similarly, I have, many wallets over here. All of these are wallets that I own. If I open a Solana wallet, for example, this has $226. I can send 15 USDC to someone else. Let's say I send it to a different wallet of mine and, click on next, click on send. A single signature is required to send it. What is a multi-sig? Multi-sig says that, bhai, you require more than one signature. Multiple people own a wallet. What is the reason you might want to do this? Just for some safety. If I currently have this private key in my laptop, but what if my laptop crashes tomorrow? Then, there is no easy way for me to recover my private key. Versus, what if I give my mother a private key? I give my sister a private key. I myself keep a private key. And I give my best friend a private key. I just break my private key, let's say, into 4 parts. That way, whenever I want to send someone Ethereum, only 2 out of these 4 people, let's say the multisig is a 2x4 multisig, which means only 2 out of these 4 people, if they get together, they can actually, send out, let's say 15 USDC to a different address. That is what a multisig lets you do. Why do you use a multisig? for resiliency, right? In case of WazirX, they used it so that multiple people need to be hacked to be able to hack the exchange. Unfortunately, it happened in their case. But usually as a person, you use this so that multiple people have your private keys. If by chance, let's say my friend loses my private key, still 3 people can, get together and pull out funds from that wallet. That is why multisigs are useful. The way they work is, first my mother will have to, create her own private key, create her own wallet. Then my sister will have to create her own private key and create her own wallet. I will have to do the same. My friend will have to do the same. Then we will generate a fresh wallet called the multisig, or call it, the parent vault. Why is it called a vault? Because this is the place where we will actually store our crypto. And this will, let's say, have all of our generational wealth of, let's say, $200. So then when creating this vault, we can say this is a 3x4 multisig, which means if 3 people get together, they can use this $200. They can pull out these $200. That is what a multisig lets you do. Today, we will be creating a multisig. WazirX also had a multisig, but as I said, having a multisig is a good thing. They weren't able to reap any benefits of the multisig because they had a different attack vector, which was a centralized website. Second jargon is DEXs, or what are called decentralized exchanges. Now this I'm only introducing because the exchange that we're building today, I don't have any market maker contacts, right? So I can't just go to Wintermute or Jump and ask them to provide liquidity on my exchange. It is also generally very hard to get market makers to make the order book liquid or even trade on an exchange in India, because India has 1% TDS. Anytime a transaction happens, the market makers need to give 1%. This is why WazirX was highly liquid. And even DCEX is fairly liquid. I don't know why that is. I don't know where they're sourcing their liquidity from. Who is coming on DCEX and making the market so liquid and giving 1% TDS? Either they're not charging TDS to market makers, or if they are, God knows who that market maker is. WazirX had this problem. WazirX was highly liquid because no market maker would come on their platform, because no one wants to trade. These are high frequency traders. They're doing a lot of trades. And if you're giving away 1% of your capital in every trade, it eats up in your working capital. So no market maker would want to make the Indian market liquid, which is why we will be using decentralized exchanges to source our liquidity. Now what that means, we'll come to eventually. But in our case, I don't have to rely on Wintermute. I don't have to rely on, Jump or any market maker. I'm not going to go to them and ask for liquidity. I will get my liquidity from somewhere else. That is where a decentralized exchange comes into the picture. Think of it this way: if you don't have people who can make you liquid, you can find this liquidity somewhere else. And in our case, that is going to be a DEX. We'll dive deeper into this when we reach the final code section. I also have a video where I've discussed what decentralized exchanges are and how they work. All right. Third jargon is market makers. This I've already explained. If you don't have a decentralized exchange, you don't want to source liquidity from there, you source liquidity from these guys called the market makers. These are companies like Jump, Wintermute, that send you first, 50, 20,000 USDC, whatever, and they make your order book liquid. They are the ones who put orders here and here, and people, match with these orders. They are incentivized to come to your exchange and, make your order book liquid. You give them a bunch of, market maker incentives. You have market maker programs. Whoever trades the most in the last 30 days gets a bike. In fact, let me just show you. If you go to DCEX right now, you'll see they don't really have a market maker program running right now, but they have a trading platform running. Whoever trades the most will get a BMW. So these are the sort of incentives that you can expect as a market maker. Not this, you get like different incentives as a market maker. But here they have said whoever trades the most gets a BMW X1. And so you can see, these two people have been trading. This person has traded for over 31 crores in the last, 30 days. This person 30 crores. These are the incentives that market makers provide. These are provided to traders, even to market makers. Exchanges provide some benefits, filling their order faster, and them being the first one who gets filled if multiple people are coming and trading, things like these. If you don't understand this, it is fine, but you need to give the market maker something so that they come to your platform and make your platform more liquid. In our case, we won't be depending on market makers. So if you don't understand this jargon, that's totally fine. Lastly, this is nothing. The jargon is called spot. It basically means when you're just trading one asset for another, it's called the place where you're trading is, it's called spot. It's basically different from something like margin. If you want your people to leverage, or margin trade, if you've heard of it, buy options, buy futures, then, they lie on a different side. If you want your users to simply swap, give you 10,000 rupees and in lieu take 0.1 ETH, then, you're asking them to trade on a spot exchange. Spot basically means simple trading between two assets, no margins, no leverage, no options, no futures, simple trading, buying one asset for a different one. Cool. These are the four jargons I wanted to quickly take you through. We will be building a spot exchange only, but Coin DCEX, if you look at it, it is not just it lets you trade on spot. As you can see, it says spot over here. It also lets you trade on margin, lets you do a bunch of other things. But in our case, we are building just this section, trading with a near limitless order book. Something like this: you give an asset, you buy that asset from someone else. Cool. Let's get into some India specific challenges. Why is it different building an exchange in India compared to any other country? All right, let's understand some India specific challenges. If you're building a centralized crypto exchange in India, there are a few regulations you need to follow. If you don't follow them, you're unfortunately, not complying with the government. What are these? Number one is taxes. God knows why India has a 1% tax on trade. So anytime you are trying to buy or sell a crypto asset, you have to pay 1% in TDS. This could be to discourage trading. This could be to discourage crypto in general. This amount could have been much lesser, 0.01, if all the government wanted was to, track people who are trading. But unfortunately, it's really high at the moment, which has discouraged trading in India, or more specifically, crypto trading in India. For example, if I go to the Coin DCEX platform and try to buy, whatever, I have some ETH now. Let me try to sell the Ethereum for USDT. Let's say I have a lot of ETH and, suddenly I'm like, I want to sell it, convert it back to INR. If I select some ETH and try to sell it, what does it say? It says includes 0.2% fee. That's the exchange fee. That is fine. Exchanges also need to make money, and hence they will charge some amount, and 1% TDS. Unfortunately, the government, anytime I'm buying or selling any asset over here or converting between two assets, will take a 1% TDS. That's a really high amount. And it will discourage people to trade very actively. People who want to just buy and stack Ethereum, I think they'll still be fine paying 1%, because you can claim this at the end of the year. This isn't tax, it's TDS that can be claimed. But that said, you can't actively trade now, else it'll just eat up your capital. If I place 100 trades, even if they're profitable trades, they need to be extremely profitable for me to be able to make any money if I'm paying 1% to the government. You can claim it at end of year, but it takes time for the year end to come. So, this is one India specific challenge that you need to worry about. This will lead to number one, market makers not coming on your platform because they don't want to you eating their working capital on every trade. Number two, it generally discourages trading as well. But you have to comply with it. Number two is withdrawals. You can't withdraw Ethereum from this platform. You cannot withdraw Bitcoin, Solana into, an address like this. Then Harkirat, how do you have $226 if you can't withdraw? Because, I got this from somewhere else. I did not buy it on Coin DCEX and withdraw to my wallet. I got this $226 from somewhere else, where that is a different question. But if I go to, my portfolio, for example, over here, or my profile, most US exchanges would let you go to a section like, let's see, withdraw. And most US exchanges would let you withdraw this, Ethereum. If they click on Ethereum, what does the Coin DCEX platform say? It says crypto deposit and withdrawals. We are unable to offer crypto withdrawals for retail customers at the moment while we seek regulatory clarity on crypto transfers. It says for retail customers. For market makers, of course, they have to allow, no, why would a market, there needs to be someone who brings Ethereum to India, right? That's market makers right now. If they're bringing Ethereum, they also need to be able to withdraw Ethereum, but Indian retail users cannot. As I said, they can only on-ramp using INR. You can deposit INR, you can withdraw INR. You can never withdraw crypto. I think you can still deposit crypto in India. So the Indian government is fine if you bring cryptocurrency in India. It doesn't let you take out cryptocurrency out of India. This also discourages trading. This also discourages people who actually want to own their crypto. The whole point of crypto was it's not in the hands of a government or, a central entity like DCEX. But unfortunately in India, there is no legal way for you to hold crypto, like this. The third jargon here is INR USDT. It's basically this trading market right here. If you go to trade, you will see many markets on spot. BTC USDT, Waves BTC. The good ones are, ETH USDT, for example, where, you can buy some Ethereum for USDT or you can sell some Ethereum for USDT. These markets exist on most exchanges. If I open any other, crypto exchange, you will see there also most markets are BTC USDC. So this is a BTC USDC market. If I go to other markets, you'll see ETH USDC market. All the markets over here are, one asset is something like Solana, Ethereum, whatever. The other asset is USDC. If you look at it, all the markets are, one of the assets is USDC. This is generally true. This is generally what market makers want to trade on. Market makers want here, one side there needs to be USDC or USDT, other time there needs to be Sol. If you ever convert your Solana for Ethereum, your Solana first gets converted to USDC, then your USDC gets converted to Ethereum. The same is true here. Most markets on an Indian exchange will be USDT and the other side will be a different asset. But there is one special market, which is this INR USDT market, which will most probably be, made liquid by Indian market makers. All other markets can be made liquid by Singapore, US market makers, but most probably these guys have zero incentive to, hold any Indian rupee, which is why most people that you see here on this INR USDT market will be some Indians. If you've ever talked to one who's making this liquid, usually very shady Indians who source some of this liquidity from Dubai without getting too deep into it. But this is one market that is slightly special. It's very hard to find liquidity for this on a decentralized exchange. It is actually impossible to find liquidity for this on a decentralized exchange. It is very hard to find people in India also who make this market, which is why if you look at it, the spread here, it's not too bad, but it can get very bad compared to the other assets that exist over here. For Ethereum and Bitcoin, the spread wouldn't be this high. For USDT, INR, it fluctuates a lot also. It goes up to 90, it goes down to 60. And it's also, there aren't a lot of people who are willing to make this market liquid, primarily because most people who will be doing this will have some exposure to INR, and a US market maker probably does not want that. That's why I've kept this as a special side note. This will eventually come when we're building our platform as well. Fourth is licensing. Most countries require licenses. There are some shady ways. There's something called reverse soliciting that you can use to open an exchange that sort of works in India. That's how most international exchanges work. For example, if you go to Backpack doesn't have an exchange in India, a license in India right now, but it can still work because it's not advertising in India. There's like some regulations. If you're not advertising in India, you won't be able to on-ramp, but you can still get Indian users. Most exchanges that you look at though, be it DCEX, be it WazirX, have what's called an FIU license. If you don't have that, you cannot connect to a bank for sure. So if you want to take users, real retail people who want to convert their INR into crypto, you will need to get a license. It's not too hard to get from what I know. It's not very expensive either. And if you are one person who owns an exchange that has this license or generally knows how to get this license, comment down in the video below. I will get in touch. And lastly, banking APIs. If I go to, DCEX and try to deposit some funds, if I go to profile and then INR wallet and click on deposit INR to wallet, it asks me to put a bank account, and then, eventually I can transfer money in. For this, I need to connect to a bank account. So, after you have a license, you can go to usually some shady bank that will, give their banking APIs through which you can let users put money, put INR in that bank and pull out INR from that bank as well. All right. These are some India specific challenges. This is what makes India special. If you're building an exchange that uses reverse solicitation, you don't have to worry about any of this. But if you are using an exchange that uses reverse solicitation, you will not get access to banking APIs. If you do get access to banking APIs, that means you need a license. If you have a license, number one, you need to deduct 1% TDS on every trade. Number two, you need to prevent withdrawals from this account and, make sure the user cannot pull this crypto out of India or out, to their own wallet. Crypto stays in the CoinDCX ecosystem. The user can only put in INR, the user can only pull out INR. Cool. Very restricted exchange if I'm being honest, but that is how it is right now. Cool. Let's understand the architecture of what we are building. As I said, we're not building a centralized exchange completely. It is a centralized exchange. We do own the user's cryptos, but it is mildly decentralized as well. The reason we have to keep it mildly decentralized is there are two reasons. Number one, as I said, it's very hard to source liquidity, or get market makers to come to your new exchange. It's a chicken and egg problem. To avoid that challenge completely, I've built it this way. Number two, it is slightly more secure if you let your users own their crypto in a weird decentralized and centralized way. They don't really own their crypto, but they can easily see their crypto on chain. There are very easy proof of reserves. What does proof of reserves mean? It means that the user can come and see, acha, my crypto is actually owned by these people. And the third thing is security. If you use this architecture, it's slightly safer than keeping everyone's crypto in a central wallet. These are the reasons that we're using this specific architecture. Bear with me, this is slightly different from most exchanges, but there are reasons why we're taking this path than the path that any other exchange would take. Let's get into the architecture of what we're building next. All right, let's discuss the architecture of what we're building today. As I said, it's not completely a centralized exchange, or it's different from how a centralized exchange usually works. It is actually closer to wallet as a service. You are actually just holding wallets for other people as a central entity, rather than being a centralized exchange where you hold everyone's asset in your own wallet. There are two reasons for me to take this approach. Again, what is the approach of a normal exchange? There are two different things over here. If you are a normal exchange, similar to coin DCEX, and what we are building today, which is, as I said, I've named it wallet as a service. A centralized exchange has a single wallet where it holds all user funds. If there are 1,000 users, all of their funds, in this case, $240 million, were held in a single wallet. Wallet as a service, as the name suggests, every user will have their own wallet. Every user that signs up on your platform, we create a wallet for them. And every user's funds are individually held in their own wallets. They can always prove on chain कि हाँ भाई, my wallet indeed has $10,000 or $20,000 at your public address for this specific wallet, let's say on chain, and prove that. The same thing you could do in coin DCEX. Coin DCEX also gives you like proof of reserves. But if you want to look on chain, you will find a single fat wallet that has $240 million. That's a little scary. Versus what we will be doing today is every user will have their own wallet. We will just be maintaining their wallet for them. We will let them swap. We will let them on ramp. We will let them off ramp. But we will not be aggregating users' balances in a single wallet. That takes away the trust problem. Okay, you don't know where your funds went. You can clearly see on chain where your funds are. Number two, it makes it easy for us to source liquidity. The problem with building an exchange is, you need to find market makers. As I said, you need to find people who can come and, sit on the order book. And this is hard to do in India. This was historically a problem for WazirX as well. They were highly liquid because no market maker would want to make the market in India, because India has 1% TDS for every transaction that happens. This is why I'm very surprised. I don't know how coin DCEX does it, or how they're able to find market makers or where they're sourcing the liquidity from. This is very hard to do. If I build an exchange today, it'll be very hard for me to get, market makers to trade on it. Which is why it's easier for me to just source this liquidity from a decentralized exchange. What do I mean by this? I mean, there are many, platforms that exist. For example, Jupiter is a famous one on Solana that lets you basically swap one asset for another. And if you're just building wallet as a service, if we're letting every user that has signed up on our platform have their own wallet, we can just let them trade by using liquidity from a platform like this. Now, how does a platform like this bring liquidity? How do they let users trade one asset for another? Do they also have market makers? How are market makers coming here but not coming on our platform is a different question. Decentralized exchanges work a totally different way. And here is a video that I've made where I've shared a little bit as to how they source liquidity. But we're not worried about that here. What we're going to do is we're going to source liquidity from such an exchange. Sourcing liquidity basically means, okay, every user that comes and signs up, I repeat, if this is your primary backend, if this is, api.exchange.com, user comes here and signs up. We will, number one, create a wallet for them. What does creating a wallet mean? Basically something like this, right? As you saw, I opened my Phantom a while back and I was able to show you, okay, this specific wallet of mine has $226. We will create a similar wallet for the user. Think of it being similar to me clicking the plus button over here and adding a new wallet for the user that has signed up on my platform. Once this wallet is created, as the user comes and, let's say puts rupees 20,000 on their platform and then converts this into, let's say, what is 20,000 rupees? It's $250. I will be putting this $250 in their wallet, and then they can literally do anything. They can themselves go to a platform like Jupiter and trade, or we can, have a very coin DCEX like UI where they can come and, swap one asset for another. But the goal is to build something closer to TipLink. What is TipLink? Wallet as a service. You come to this website, you sign up. I've signed up using my email. They have created a wallet for me. And, I can put money in this wallet. I can trade using this wallet. I can, swap using this wallet, so on and so forth. This is exactly what we want, right? We want a place where users can come. They can put in some money and they can trade using that money and then eventually withdraw. The only difference between TipLink and our website is going to be, okay, we are going to allow INR deposits, not right now, of course. We will need a license to be able to do that. So we'll be faking that part out. But the only difference between the website like this and a website like ours would be, we will let users trade through INR. But other than that, what we're building is closer to a website like TipLink and less closer to a website like CoinDCX, even though functionally they both do things that are fairly similar. Harkirat, how are they different? If you're saying they do things very similar, they are different. Architecture wise, they are different. Security wise, they are different. But the biggest difference between both of these is going to be, if this is an exchange and this is what we're building, wallet as a service. Exchanges are extremely fast. The reason for this is they are running on centralized systems versus what we're building will be mildly slower since we'll be putting all transactions on chain. This also has the downside of gas fees that we have to pay every time we do a transaction. The same thing happens here. A centralized exchange will also charge some trading fee. But this is slightly more unoptimal that way. Every trade that happens actually happens on chain. It will be very hard to do for a chain like Ethereum, much easier to do for a chain like Solana. The other problem, with this specific approach that we're taking is the government won't be super happy about this. You are sourcing liquidity from random people. You don't know where you're getting Solana from. You are just, getting it from a decentralized exchange. The name itself says decentralized exchange, which means anyone can provide liquidity here. You don't know who's providing liquidity. The government is not going to be super happy about this. If you're allowing users to buy Solana from your platform, and that Solana is coming from North Korea, the government is going to have a problem. So why is that better here in a centralized exchange? Because you KYC both your users as well as your market makers. Both of these need to KYC on the platform and only then can they trade, versus here the market maker does not need to KYC. We don't even know who the market maker is. We are just sourcing liquidity from a random decentralized exchange. Those are the downsides of using wallet as a service. But what are the upsides? The upsides of using a wallet as a service compared to a centralized exchange is, number one is safety. It is mildly safe, for if I'm being honest, if you screw up here and you'll lose funds here as well. But since every user has their own wallet, your funds are distributed in millions of wallets compared to a single parent wallet holding all of them. Number two, it's slightly easier proof of reserves. Proof of reserves basically means proving to the user that you actually hold their funds. Since this is a centralized entity, a centralized exchange, and the user wants to check, are you actually holding my Ethereum or not? Here it is fairly easy because you can just give the user their wallet address. For example, if you look at TipLink, I sign up here, I put some money, let's say I put some money from my bank account. It clearly shows you your wallet address. What is this your wallet address? It is the address of the wallet that they are holding for you. As I said, it is wallet as a service. You have a wallet now, but it is being maintained by the folks at TipLink. it totally makes sense to do that for a centralized exchange. You want to have some restrictions on your users. If you have an FIU license, if you are an exchange, you can't allow users to own their private key, but at the same time, you can hold it for them. That is exactly what TipLink does. And it gives you a single place here. This is your wallet address. You can copy it and you can go to any block explorer and confirm. For example, if I go to soulscan.io and go to this wallet address, it clearly shows me that I do have $11.46. They are holding it for me on chain. Whatever assets they are telling me I hold, if I go back over here, they tell me I own 0.064 Sol. I can actually go on any block explorer and confirm that I do indeed hold 0.064 Sol. That is the benefit of this wallet as a service approach compared to a centralized exchange, where you can still do proof of reserves here. It's not like you can't do proof of reserves, but they're not as easy as, wallet as a service. The third benefit here is if the Indian government ever allows you to eject out of centralized exchanges, they let you withdraw, then it's very easy for the user to just eject out. You can just give them their private key and they're good to go. They can actually own their crypto, versus in a centralized exchange, it's just numbers on a screen, and you can't ever be sure that your crypto is actually held by the exchange unless you withdraw, which currently you cannot withdraw from any centralized exchange in India. Cool. That is why we're going with this approach. Let's look at the architecture of this approach. Again, what we're building is closer to something like TipLink, but this is a conscious choice for number one, safety, but number two, since we don't have any liquidity right now in India, this is the easiest way for us to source liquidity and let our users trade from day one, compared to us building a centralized exchange like this and then first finding people who can let us trade. Cool. Even in our wallet as a service approach, we will have to find some market makers. I will explain that, what exactly those market makers are and why we need them in the next section. Let's get into the architecture of building something like this. All right, to make things slightly easier to digest while we're coding, I've broken this down into two parts: the easy implementation and the hard implementation. This is the right implementation, what we want to do eventually. But before we get there, let's just focus on an easy implementation so you can, at least digest what is happening and have a simple V1 out. The steps are going to look like this. We will first create the front end, very simple sign up page. The user can come and sign up using Google. Then we will let the user, we'll create a wallet for the user and store their wallet credentials in a database. This is highly scary. You should not do this when you're creating a wallet as a service. When you're creating an exchange, your private key of wallets shouldn't be stored in the database. But just to keep things simple for now, we're going to just store the user's private key. Everyone who signs up gets a Solana wallet. We will store their wallet. We will manage their wallet. We'll store their wallet keys in our database. We'll be mocking out two things over here. We'll mock out on-ramps, basically. We'll have a button that says deposit INR, but that will not do anything. That will just let the user, deposit some random INR for now. Letting the users convert INR to USDT. This is another thing we will be mocking because we don't have INR USDT market makers. If you remember, I said the INR USDT market is slightly special. You need some, you can't find this market on any decentralized exchange. So we're going to mock this out for now. Eventually the goal needs to be, we are able to get these people, the people who are making the INR USDT market on, let's say, coin DCEX, the people that are sitting on this order book, we need to get them to our exchange and ask them, we also have users. They also have INR. They want to convert it to USDT. We can provide you users. You provide us liquidity. So these market makers is what we will need to bring to our platform eventually. For now, we don't have them. So we're just going to mock out this and this. There are other things we can do here as well. Use services like on-ramp that, let users on-ramp from INR to crypto. But we want to own all of the systems since we are an exchange. So we'll be going down the harder approach of getting market makers on our platform. Then we'll be adding spot, letting users swap, Solana for Ethereum, USDT for Solana, things like these, sourcing liquidity from a DEX. And lastly, we'll be discussing the attack vectors here. This is a highly insecure approach, but we'll have a V1 ready that will sort of work, but will be highly insecure. Then we'll go through the harder approach that uses multisigs. I'll explain why this approach is better than this one. And, then we'll try to implement this as well. Cool. Let's get into the coding bit. Let's start by coding just the first part, which is building the front end. Simple sign up, sign in logic. When the user signs up, they get a wallet. We store that wallet in our database. That's it. All right, let's get into the coding bit now. There are a bunch of steps we have to follow from top to bottom. There will be some blockers that I can already think of that will come. But let's try to tackle these one by one and then understand the blockers and see how we can fix them. Let's get into the step 1 and step 2 over here, which is creating a very basic front end where a user can come sign up and see, their wallet address, let's say, and their balances. Initially, of course, the balances would be 0. We need to add the sign up logic and the sign in logic. Storing the wallet credentials in the database. These two steps can sort of be clubbed together. Whenever a user signs up, we need to create a cloud wallet for them. Again, what are we building? We're building a wallet as a service. We're building something closer to tiplink.io where a user comes, signs up, and when they sign up, for example, if I go to tiplink over here and sign in with one of my accounts, I can see a wallet that looks something like this. As you can see, it's saying preparing your tiplink account. This might take a few moments. It's preparing a wallet for me. And now it has created a fresh wallet with $0. Very similarly, we'll be building, maybe a UI very similar to this, and also, all the functionality very similar to this. Let's get right into it. Let's start with the front end, the database, and the wallet generation bit. I'm going to call the project DCEX because it's a centralized exchange. And here I'm going to create a new Next application. I'm using Next as my front end framework. Feel free to choose whatever you want. I'm going to name this front end. I'm going to select defaults for everything and wait for this to finish. Once it does, I'm going to open this fresh project in Visual Studio Code. All right, I have the front end open in Visual Studio Code. Let me quickly create a very basic sign up page using nextauth. Nextauth is a framework that lets you bring authentication into your Next.js application. That's what we'll be using today as well. I'm installing nextauth as a dependency. The next step usually is creating your nextauth route handler, which in case of Next.js, if you're using the pages router, you can go here. If you're using the app router, you have to do something else. Let's see if we can find it. App router. There you go, something like this. So we need to create app/API/auth, app/API/ global route handler. What this .nextauth means, any request that's coming on /API/auth/ anything will be handled by this route.ts file, inside which, the handler comes from the nextauth library. Here is where I need to add all of my, providers. Right now we're just supporting sign up /sign in with Google. In the future, we might add, other providers as well. So providers is going to be an array where for now we're just going to support Google. Something like this. Providers Google provider, there you go. Client ID and client secret. Now I need to get this client ID and client secret by creating a fresh OAuth app on Google GCP. So I can go to GCP, OAuth credentials, over here, and create fresh set of credentials for what we're creating today. It's a web application. I'm going to call it Exchange. Add JavaScript origins. For now, it will be localhost :3000. Add authorized redirect URIs. You need to add this. I don't know what the exact redirect URI is, so I'm just going to create it like this, and eventually we'll add this when we reach an error / find an error. So let's create a global.env, inside which I'm going to add Google client ID equal to this thing and Google client secret equal to this thing. That looks right. Cool. What else? I need to maybe create a basic front end so that the user can actually log in. So inside my home, I will, or maybe not even inside my home, in my layout.tsx, I can add an app bar that appears at the top of every page. This app bar I will define over here in a folder called components. Let's call our application DCEX for now, and this is going to have either a login page or a logout page based on session.data.user. If it does exist, then we need to first create a button component that we can use. Tailwind buttons. This black button looks fine to me, so I'm going to just copy the styles of this button from here. I'm just trying to create a generic component that I can just use everywhere through my application. Children on click. Children, that looks right. I've created a generic button component that I'm going to just use throughout my application. I can also do one more thing here, get rid of all the dark styles. I'm going to name this primary button. On click equal to sign out, and the body is going to be log out. Why is this giving me a type error? Cannot find primary button. Else the user will see a sign in button. So if the user is logged in, they will see a sign out button, else they will see a sign in button. That takes them to the nextauth page. A the nextauth authentication page. All right, is that enough? That probably is enough. I can go to layout.tsx and import the right app bar over here. And let's see if that works. Again, what have I done? I've defined an app bar in the layout.tsx, which means it will show up on every page of ours now. And the app bar is simply a top level bar which has some border at the bottom, some X padding, some Y padding, and has two children which have flex between them, and the content is justified between, which means this will come on the left, this will come on the right. They will be equally spaced towards the corners, which is sort of what you need in a top bar. If I run npm run dev, I'm in the wrong folder. Npm run dev and go here. It tells me React context is okay. I need to make app bar a client component. And I need to wrap my whole application inside a session provider. So if I go to layout.tsx, I need to wrap everything inside a session provider, but usually what's done is something like this. You create a providers.tsx file from which you export, just increase the size a bit. Export const providers, and we just need the session provider for now. I can also just copy this from another repository of ours. This is standard if you want to have providers throughout your application. For example, this other repository has where is this? The session provider that comes from nextauth, the theme provider that comes from most probably this will use some Tailwind theme provider, recoil root that comes for recoil. You shove all of them in a providers.tsx, which is a client component. The reason you do that is because you want all of these providers need to be in a component that's a client component, but you want to make sure your layout isn't a client component. Layout.tsx shouldn't be a client component. You should not have something like this at the top of layout.tsx, which is why you wrap everything inside a providers.tsx, which you just use over here. Session provider children, I can just copy this from here. React node. That should do it. So what have I done? I tried to run the application. It gave me some errors because I was using this use session hook that comes from nextauth/react. I can only use this hook if whatever component is using that hook, which is app bar, is wrapped inside the session provider. And the session provider I can directly add here as well. But if I add the session provider directly here, I will have to make the layout.tsx a client component. To avoid that, I create a special file called providers.tsx where I'll be introducing all of my context providers. Session provider is the only one we have right now. In the future, we might have more. We'll just add all of them here. Let's see if this works now. If I go to localhost 3000, I see DCEX on the left. I see sign in button on the right. It's all black right now. So let's go to global.css and remove all the styles other than the Tailwind styles and refresh. Looks slightly cleaner. Let me go to the app bar and also style this a bit. Class name equal to font-xl or text-xl, font-bold, flex, call, justify. You can use AI to, make your life easier here a bit, or, go be a little faster. I'm not, but, feel free to. There's no downside to using. I mean, if you're learning, then don't. Otherwise, you can. If I had flipped on Super Maven over here, I would be coding at, twice the speed at the very least. All right. I have the sign in, the landing page. It just has this thing right now. I can add some, UI over here if need be. Let's see what the tip link or, whatever the WazirX or coin DCEX UI looks like. It looks something like this. All things in crypto right here. Trusted by a few people, download the app, FIU license registered, bunch of other things. So if you want, you can build something like this it can be a v2. I'm not okay, let's do it. I don't want to hear backlash. Okay, this has been made half-hearted. Anyways, we have to build a landing page. Might as well just copy maybe tip link. I don't know. I don't think it's a good idea for me to just copy an Indian exchange. So let me copy tip link right here. What does the landing page look like? Looks something like this. The crypto of tomorrow today, something, sign up with Google, and then a bunch of UI components. Cool. I think this is good enough. Let's try to copy their front end. So if I go to the landing page, the first thing I need to add here is this hero section, which has this, and this. So let me create a hero component, which will render all three of these things. Components hero.tsx. Font dash, I don't know, 4XL. Sorry, text dash 4XL, font dash extra bold. The crypto of tomorrow today. The Indian cryptocurrency revolution. All right, let's see how it looks. Refresh. I don't see anything. That is because hero isn't imported. Let's make it slightly less bold and slightly bigger. That's a little too big, is what she said. 4 is a little too small is also what she complained about. So what can we do? There is no 6XL. Oh, there is a 6XL. Then there might be a 5XL as well. Semi-bold. Font weight. Semi-bold is there. Okay, let's try medium. Revolution needs to be blue. Ugh. If you can't already tell, I hate doing front end. What is it? Text dash blue dash 400 500 PL dash 2. Looks decent. Create frictionless wallets with just a Google account. That's a very good pitch, actually. That's exactly what they've built and what we're building. Might have to just copy this wallet from India account, convert your INR into cryptocurrency. All right. How was this centrally aligned? I didn't do anything to make it centrally aligned. Oh, it's because of this parent that has item center. Makes sense. Class name equal to flex, justify center pt dash 4. Font size is going to be slightly bigger, so let's say text dash XL. Excuse me. All right, we need a button that looks something like this now. All right, that looks decent. Secondary button, login with Google, on click equal to sign in with Google. Prefix needs to be optional. Right, let's see. So their page, this is our page. Looks pretty bad because we're using a button here, so we need to make this a client component. All right, decentish. Our blue is not bluing, so let's make it 400, 500. Looks close enough. And add some padding here. All right. Now below this, we should add a bunch of screenshots. We'll get screenshots after we've built the platform. So let's just leave it here. If I click on login with Google, it says sign in with Google button, nextauth custom button. It's exactly what we need. Sign in Google, sign in from nextauth/client. P extends providers, email or credentials. P extends this thing on different file. That looks right. Sign in with Google. Let's try signing Google here. Here also there's an error. Okay, makes sense. So it's just that our login with Google is bonked, most probably because ugh. Yeah, no wonder it's bonked. What is happening here? Oh, my bad. All right, let's try that. Login with Google, still bonked. Let's try to log these. My current speculation is that the environment variables aren't correctly propagating. Yeah, client ID empty, client secret empty, even though I have this defined in a .n file. Might be that the .n file needs to be one folder up. Oh, it is. Of course, it needs to be one folder up. It's in the wrong folder. It needs to be in the front end folder. Now let's try it. Let's go back to the landing page. So our root folder has, a front end folder inside which I should have added the .env. Added it to the root folder, which is why login with Google wasn't working. Now if I click on it, it takes me to the Google page and says cannot sign in because of the error details. It gives me the exact redirect URL that I should have put originally. I did not put it because I wasn't sure what the exact redirect URL was. It's /auth/API/auth/callback/Google. So that is something I need to add over here. So if I go to Exchange, if I add a redirect URI, it looks something like this. Now hopefully it should just work. If I click on login with Google, it takes me to this page. I can select an email and wait for it. I log in. As you can see, there's a logout button here. I should also change this to go to dashboard if the user is already logged in. So let me do that. Let me go to page.tsx, go to the hero component, and here if the user is already logged in, so let me do something like this: const session equal to use session. Session dot data dot user. If the user does exist, then the button should say go to the dashboard. Else it should say something like this. So and this should navigate the user. Navigate. Just making sure we're still recording. Got a mini scare over there. What is this? Use navigate is over. Use router, sorry, my bad. Router equal to use router. And here we'll do a router dot push dashboard. And the user should also go to the dashboard. We should just define a simple dashboard page here. So since we have file-based routing, all I have to do is add dashboard slash page.tsx export default. Alrighty. Okay, I'm already logged in. It says go to dashboard. If I log out, it says log in with Google. If I log in with Google, it says go to dashboard. If I go to dashboard, it takes me to the dashboard page. Alrighty. Next step is we're already almost done with this first. Well, we're not done with the first one. We need to add database logic. We need to, persist this user into the database. We also need to, when we're doing that, we also need to create the wallet for the user and persist the wallet in the database as well. So that is going to be step 2. I'm going to define a schema for the user, and once the schema is defined, I'm going to, when I'm creating the user, I'm going to create a wallet for them and store their private key, public key, everything in the database. For now, I'm repeating, this is bad. You should not store people's private keys in your database. But for this V1, we are doing that. For the V2, we have a slightly better approach. Alrighty, let's do this. We want, when the user signs up, we create a wallet for them. So we can go to the nextauth configuration. And here, add a callback for nextauth.js callbacks. We basically need a callback to run anytime the user signs in. Next callback. They have a sign in callback, which probably is exactly what we need. If user dot email, I should log some of these things. Let's log all of them and see what information exactly do we get when the user signs in, and then go from there. We might need some of these. For example, we might need to ensure that the user is, they have a verified email, and only then allow them. I think with Google it just might always be verified. I don't know. We'll see. I log in and I get back a bunch of things here. Profile.email_verified, and we get the name, which we probably should store as well in the database. User.name image account.provider. All right. So here is one extra, finicky thing that I'm just, being overly obsessive about, because this is an exchange, which is if the provider is not Google, then return false. Don't let the user log in. Right now we're only supporting Google. In the future, if we support other things, we'll allow other ways to log in as well. Now here, const email equal to user dot email. If not email, then again return false. But if the email does exist, which means the user logged in correctly, we need to check in the database if the user already exists, which means we need to now create a fresh database. So npm install Prisma to, we already did this, right? We did. So now let's add our models. Specifically, we'll have a user model where we can have the email. Is email the right name for this? Probably username, because in the future we might have other providers as well which are not email. Let's say phone number. So an ID, which is the actual ID, string defaults to UUID, username, password. Is that good enough? That's probably good enough. Model, Sol wallet. For every user, we'll be creating a Solana wallet. So this will have an ID. It'll have a public key, which will be a string. It'll have a private key, which will be a string. It'll be associated to a user, so it'll have a user ID, which will be again a string. Now a user can have multiple Sol wallets if you want to get really fancy, but let's have a one-to-one relationship for now. Which means every user will have a Sol wallet ID string. Let's make this optional. And every Sol wallet will have a user ID, which will be compulsory, and they will have a user, which is a relationship. So what are the relationship user? It's not a valid line. Error passing relation. One-to-one relations must have a unique field. That is right. This needs to be unique. And there we go. Alrighty, boy. That took a long time. Cool. Every user will have a Solana wallet. Every user will also have some INR balance, unfortunately. I don't think we'll be using this, but let's still create a, just like they have a Sol wallet, they can probably have an INR wallet where we'll be storing their balance, which will be an integer, and every user will have a single INR wallet. Alright, this is what the schema looks like for a V1. Every user will have an INR wallet. Every user will have a Sol wallet. All of their Indian rupee will be, maintained by us over here. the value of this balance will only go up if the user actually sends money to our bank account through most probably a webhook. The Solana wallet, we just maintain the public key and the private key. The actual balances are stored on chain. So the users, Solana balance, USDC balance will all be on chain. This looks like a fairly simple schema. This is one-to-one and one-to-one relation. A user will have a single INR wallet. Every INR wallet will be associated to a single user. A single user will have a single Sol wallet. A Sol wallet will be associated to a single user. Now what we need to do is when the user signs in, we first check if the user already exists in the database. So const user equal to, we first need to create a Prisma client, which again is tricky in nextjs. In nextjs, if you simply do this import Prisma client, we first need to generate the client, which means we need to migrate, which means we need to create the database. So I've initialized schema. I have not yet created a database where I'll be, storing my data. So let me see if I have some Postgres running locally. I don't. Let me start Docker. I'm just starting a database locally where I'll be storing the data locally. I'll also migrate that database, which basically means I'm going to put a table in that database. Since it's a Postgres database, I'll be putting these, users table, INR table, and Sol wallet table in the database. Docker has started. Let me start Postgres locally. The way to start Postgres locally is docker run -p, a port mapping, an environment variable for the password, and the image that we're running, which is Postgres. You can start it other ways as well, whatever way you want to use to start Postgres locally. If I open my .env file, I have the database URL. I need to replace this with my local Postgres database, which has this specific password, my secret password, localhost at 5432/Postgres. That looks decent. Now I can migrate my database. npx prisma migrate. This should actually put entries into my database, which means it should create tables. In fact, if you look at this prisma/migrations/ this file /migration.sql, you can see a bunch of SQL queries: create table user, create table INR wallet, create table Sol wallet, so on and so forth. All right, cool. Yeah, that sounds right. Now we can start to write the application level code, which looked something like this. Before that, as I said, we should create a db/index.ts file. The db/index.ts file will simply export the Prisma client. So export const Prisma client equal to new, something like this. But this becomes problematic in case of nextjs. Try to do this. When you do this, you'll run into a bunch of issues. When you run into those issues, you can Google how to fix those issues. It will eventually point you to this solution, which I just have in one of my repos. I'm just going to copy it. Basically something like this. Rather than exporting Prisma client by initializing it, we create a singleton. If you go from this file from top to bottom, we define a function that actually initializes the Prisma client. We don't initialize Prisma client outside raw, so that if any file imports it, it isn't necessary this code actually runs. And we actually run this code only if global for prisma.prisma doesn't exist. What is global for Prisma? It's just the global object in nextjs, and this doesn't change across recompiles. What is a recompile? Npm run dev. I'm going a little too fast here. Basically, if you do what we were doing before, I'm hoping you understand this. Okay, we are initializing an instance of our ORM that we want to use everywhere. What happens is, if you're running npm run dev locally, and you keep running npm run dev, you keep recompiling your code, this file gets recompiled, you create a fresh Prisma client, you have a bunch of connections open to Postgres. Postgres starts to scream, okay, I have too many connections open, my max connections limit has been reached. And hence what you do is the thing that we've done here, which is, okay, only if the node environment is not production, if you're running this locally, then global for this .prisma equal to Prisma. When this file runs for the first time, we create an entry in this global for Prisma object, which is nothing but this global this object. This will make sure across recompiles, if npm run dev compiles again and again, and if the environment is not production, the global for this .prisma exists, which means we don't reinitialize Prisma client singleton. This function only gets called once if you're running this in dev mode. By dev mode I mean when you're running npm run dev locally. In production this will run multiple times, which is fine, because in production you're not recompiling your code again and again. But when you're running it locally, you're recompiling your code again and again. This file runs again and again, and this line of code makes sure that Prisma client singleton only runs once, which means new Prisma client only runs once. We only initialize this once. There are blog posts that explain this a little more detailed. You can reach those blog posts. If you don't do this, and you'll reach a maximum connection limit on your Postgres pool. All right, localhost 3000 now gives me another error. What's the error? Oh, okay, I have not finished this. So const user equal to const user db equal to Prisma. Okay, so db, we need to now import db from @/app/db. This is the thing that I just wrote in this db/index.ts file. I'm now importing this export, which by default it exports this Prisma object, which is nothing but a new Prisma client. I'm importing it here so I can start to talk to my database. What I want to check is there a username with a specific email? And if there is, then it's fine. The user already has a private key. This is the user signing in. The user isn't signing up, the user is signing in, which is why you can simply return true if user db exists. So if user db, return true. Else we need to store some things in our database. So we need to do something like await db.user.create data username password. So it doesn't have a password. Password needs to be optional, especially if your provider is Google. So we need to change the schema a bit. Password needs to be optional, and there should be a field here called provider, which needs to be an enum. And right now we only support Google. So Google is the only provider over here. Eventually we'll add Facebook, GitHub, whatever you want to add. Let me migrate my database. npx prisma migrate dev, added providers. And here let me do a username is email. And okay, why is this complaining? What are we missing? Provider is missing, which in our case of course is Google. And also we need to initialize a Sol wallet for the user. Can you do this? Say create ID public key private key. Ooh. Public key, let's say an empty string. Private key, let's say an empty string. That looks great. And similarly INR wallet create needs to have what? Just the balance, which is going to be 0 for the user right now. That looks good. The only thing is the public key and private key need to be a real public private key on the Solana blockchain. So the next step is initializing a real wallet for the user here. For that, you can use any library. There are like many libraries that let you do it. Solana/web3.js is one. There's one called tweet and ACL that lets you do the same thing. You want to create a public private key that's valid on the Solana blockchain. There are many cryptographic libraries that let you do it. The one that we are using is Solana/web3.js. This library, these are like common libraries on every blockchain. You'll find web3.js for Ethereum. At Solana/web3.js is a similar thing on Solana. It exports something called the key pair, which, as the name suggests, is a pair of keys, a public and a private key pair. And that's exactly what we need to store here. So we need to initialize an empty key pair for the user. You can do that by doing something like this: key pair equal to key pair dot generate. This generates a random public private key pair. Harkirat, what is a public private key pair? Basically this thing you see right here. If I showed you my Solana wallet a while back, my Solana wallet has this public key that I can share with you. It also has a private key that I shouldn't share with anyone. If I share that with anyone, they can pull out my funds. So this is what we're generating for the user. That's the whole point of our website, right? It's a wallet as a service, which means this public key needs to be generated for that user, similar, and the private key as well. That's exactly what we do here. Const public key equal to key pair dot public key. Now this is the object of a class called public key. If you want it in this format, string format, like we have it here, 8fcx, you have to convert it to, you can just call toString. I think that would do it as well. But 2 base 58 is the most common, encoding in which you share your public key with everyone. That's the encoding here as well. 8fcx is in base 58. That's what we convert this public key into. And the private key, you can convert this into a string also, or you can convert this into, this I guess already is in an array of bytes. Let's see. Private key is declared as it's a uint8 array. What is a uint8 array? It's basically an array of bytes. What is uint8? An integer with 8 bits, or 8 bytes, 8 bits. It is an integer with 8 bits and an array of that. Basically, let's just log this one so you can understand this slightly better. This is what we want to store in the database as the public key. This is what we want to store in the database as the private key. Let's also store these so we can just inspect them in the database. Finally, private key dot toString. Alrighty. npm run dev. Let's sign up and see what public key and private key gets stored. Again, it will get logged here as well. How did I generate the public and the private key? I use the key pair dot generate function that comes from @solana/web3.js. Are there other ways to create a key pair on the Solana blockchain? Yes, there are many other libraries that let you create what's called a ED25519 key pair. This is basically the hashing algorithm that Solana uses, that you can use to create a public private key pair. So you don't necessarily have to use this library. Any library that lets you create a ED25519 key pair, you can use in this specific section and generate the public and the private key for the user. All right, let's try to run this and sign up. Since this is the first time I'm signing up, it should hopefully log a public and a private key for me. Login 100xdevs@gmail.com. Let's see what gets logged here. Let's see if the control even reaches here or not. All right, as you can see, it logged a public key for me. It also shows me a bunch of warnings. It also logged a private key for me. The private key, as I said, is uint8. So it's 8 bits. I think it goes up to 256, starts from 0. So it's an array of bytes. It's an array of bytes. What is a byte, Harkirat? Any number between 0 to 255. So if you look at it, every number over here is 2 is 1 byte, and this is a 1, 2, 3, 4, probably a 32 byte array, 64 byte array. So the private key is a 64 byte array. The public key is, we've converted it into base 64. So it's just a simple string over here. This public key is very similar to the public key that you see in my Solana wallet. My Solana wallet's public key is this. It's a public key, which is why I can share it with you. The private key of my Solana wallet, I can export if I want. I can go to, the settings over here and export it. But if I export it and show it to you, then you have access to my funds. So you shouldn't export it. Alrighty. Cool. I think this might have been stored in the database as well. I forgot to store return true over here. But if you remember, what was my public key? 3J150. Let's try to log in one more time using the same email and ensure the same, public key remains in the database. The public key doesn't keep changing for the user. We should make sure this private key isn't overridden. If it's ever overridden, you've lost the private key of the user. So the user should only be able to generate this private key once. Let's see npx Prisma Studio to inspect our database a bit. If you look at our database, it has one user now, 100xdevs@gmail.com. Provider is Google, and that specific user has a Sol wallet whose public key is this 3J15 that we had generated for them. The private key looks something like this. The private key is a string which has, it's not a uint8 array that's stored in the database. It's a string, but that is fine. You can always parse this string and convert it into a uint8 array whenever you want to use it. And this is the user ID for the user. Similarly, we have a INR wallet for the user, which has a balance of 0. Hopefully that's straightforward. Maybe it's not. Let me know if it isn't. But now we're reaching very close to what tiplink does. If I go to tiplink.io and sign in, it's called tiplink.io only, right? No. If I log in over here, let's say I log in with the same email on tiplink.io, you will notice it creates a wallet for me. It lets me get my wallet address. It shows your wallet address. It lets me copy my wallet address. It lets me view it on SoulScan. We want to do something similar. So once the user logs in and they open their dashboard like this, we want to show them a similar screen where they see their name, maybe see their profile picture, see their balance, which will be 0 initially, see their wallet address, and then India regulation doesn't let you withdraw, so no point here. But India regulation does let you add funds with banks, so you can probably mock out some of these. And we should definitely add swaps to. That's the basic functionality that an exchange needs to support, right? You can swap one asset for another. Cool. Let's get into it. Let's finish this dashboard bit next. All right, next steps according to the list that we had created are mocking on ramps and letting the user convert INR to USDT. Both of these are going to be mocks basically. If you open something like tiplink, when you come over here, you initially of course have 0 rupees. As you look at my current balance, it will be $0. I have 0 Solana over here, $0 for balance. How can the user put in funds? We were thinking, or I had originally thought, okay, we will mock the on-ramps. What does mocking on-ramping mean? Mock an endpoint where the user can come and, get 10,000 rupees in their INR wallet. But I'm thinking whether or not we should do that because I want this to reach production on day 0. Whenever this video releases, I want everyone who's part of the cohort to be able to, pull out maybe like 50 cents or $1 worth of Solana into their whatever tiplink or whatever we'll call it DCEX account. And hence, I will most probably not be mocking the on-ramps. I'll have 0 mocks. You can use this still, but you can't on-ramp yet. I'll probably have an add funds button that will show, okay, we don't have an FIU license right now. So you please wait to deposit INR balances and everything else. You can still deposit via crypto. You can still swap. These are the 2 features that we'll still add. All right. So we're basically skipping these 2 and directly adding spot and getting liquidity from a DEX. And another thing I'll be adding is I'll create an email list of everyone who's bought the cohort, and I am going to, let them see a button over here called airdrop that will airdrop real Solana to them, so they can, have a balance of whatever, $1, let's say. I'll do it for, let's say, 500 people. So I'll put a $500 bounty for 500 people to pull out a single dollar. That will also be an interesting, side quest to build over here. And, to bootstrap the project. If I have $500 on the project, I know, everything I'm doing is hopefully safe because, if not, then I'll lose $500. So it's good incentive for me to build this the right way. All right, let's add spot and liquidity. So I first need to, copy over this card over here. So let's quickly do that. One thing I need to do is store the user's name in the database as well. So let's do that first. Let's go to the schema, and every user will have a name as well. And maybe a profile picture, which will be an optional string. And now we need to store both of these in this route. So here you do create the user. You also have to provide them the profile. Okay, let's first migrate the database. Let's make the name optional as well. So here now I need to add a name and a profile picture. String only, right? Okay, there we go. Why is this still giving me errors? Username. Why don't I see INR over here? User now has name and profile picture. Let me regenerate the client one more time. Create user input has username. Oh, it has profile picture, it has name, right? There we go. Okay, there you go. Now we need to extract the name from this profile, most probably, I would assume. Oh, oopsie daisy. Profile dot name and image. Hopefully that does it. Let me clean the database. So we have a fresh start, and the user that we add has a profile picture associated. So go to the user, maybe go to the Sol wallet and delete that first. Then go to the INR wallet, delete that. Then go to the user, delete that. Alrighty, npm run dev. Log out, log in, sign in with Google. And hopefully the database now has a user's entry with my name, Harkirat Singh, and with a profile picture, hopefully. Now it doesn't have a profile picture, which is fine, but would have been nice. Let's see, I did see a profile picture URL somewhere here. Shoot. Sign in, Google. And oh shoot, I logged it at the wrong place. Okay, so it's in profile.picture. What did I use? I used profile.image. Hopefully that does it. Let me again clean up the database. Let me restart. Log out. Alright, I do have a profile picture now, which points to something like this, so we're good to go. Now let's create the front end. Don't know what came there. All right. Here I need to show the user's name and everything. Name over here, image over here. So first thing I probably need to do now is return some extra things over here. In one of these callbacks, I need to, so let me just share what I'm saying. Let me go to this dashboard page. Here, if I do const session equal to use session, and I try to log session dot data dot user, you will notice that it has my name, it has my email, it has my image also. Oh, it has everything. Okay, so we're good to go. In that case, I can just create this, you know, I'm going to call this pt-8, and then inside this we'll create the max w xl rounded shadow Okay, that looks close to what we have here. Maybe the image needs to be a little bit bigger. That's a little too big. Account assets. Alrighty. The next one is going to be the most important one, actually. The assets component that is going to render the user's asset, which means we need to find the current value of all the tokens that the user has. Yeah, that's going to be hard. All right. So it's a wallet address. Boy. Okay. This is a client component. We need a server component that calculates state before we reach here. So let's make this guy. That looks good. Now this is a server component in which I can grab some things from the server or from the database. So this will be weird to people who've not done server components before, but basically you can now write inside your component, convert this to be an async component or an async function, default async function, this thing, where you can get, let's say, balance for this user, which can literally do import db / db dot user dot sol wallet dot find one user dot oh, there's no ID here. That's bad. Server session does not have an ID. Session dot user dot, oh boy, we need the ID. Yeah.
1 hour later.
All right, it took me almost 30 minutes to solve this specific error. Let me give you a brief of what it is. When you're using nextauth, right, by default, the user object that you get here, the session object more specifically that you get here, if you look at its type, let me quickly show you. Where's the default? There you go. Default. It looks something like this. It has a name, it has an email, it has an image. It does not have an ID by default, or a UID. So if you want to put your database UID into the nextauth session object, you have to go through a bunch of hoops. Let me quickly share what those hoops are. Basically, step one is where we had defined our nextauth config, right? this specific route endpoint that exists in API auth.nextauth/route.ts. We abstract out all of this logic into a function called the auth config, because we need to use this auth config someplace else as well. I abstracted this out. I stored this in a file called lib/auth.ts. Lib is just a new folder that I created where I'll put all, auxiliary files that are not front ends, not back ends, no route handlers. Here, I define another type or interface called session, which has a UID. I don't think we need this at all here. I define another type called session, which extends the original session and adds a UID field to the user. And you have to play a bit with the callbacks over here. If you remember, we used the sign-in callback right now, but it also provides you a JWT callback and a session callback. A JWT callback is called anytime a JWT for a user is created. JWT stands for JSON Web Token. Basically, the first time you log in, the token that is created for you, the control would reach here once. And when it does is when we, get the user from our database. Maybe one more thing I should tell you first is when the user signs in for the very first time, now in the database, we are also storing their Google provided ID. Whenever you log in via Google, Google gives you an ID for the user. We store this ID in the database. If you look at the schema now, the schema has changed a bit. I've added this sub field over here, which basically represents the external user ID, the Google user ID of the user. When the user signs up or signs in, we store this sub field in the database. When the JWT for the user is created, which will be created every time they log in, we get the user which has the same sub in the database. This is how we are able to fetch our user ID rather than the Google user ID, and we put that UID in this token. This token basically is what gets wrapped in the JWT or gets converted into the JWT. And lastly, every time a session is created, a session basically means temporary session between the client and the server. Here we again override the UID to have the token's UID. So long story short, anytime a JWT is created, we store in the token our database UID, and anytime a session is created, we store in the session again this specific database user ID. If you don't understand this much, you should go through this. That is what I went through as well. Let's see, callbacks in nextauth, and it will pretty much tell you what this JWT, what the session callbacks are for, and play with them a little. You'll be able to eventually get access to the user ID over here. So db.solveWallet.find first, user ID session.user.uid. Why were we doing this? Because we wanted to get the balance of the user. So for that, we need the public key of the user. So const user wallet equal to await this thing. If not user wallet, then you have a problem. Return error, no Solana wallet found associated to the user, but that will never happen realistically. Anytime a user is created, we create a wallet for them, and hence we'll just get their public IP just to be too safe. Like we should only select their public key over here and not select the private key, because you don't want the user to ever be able to see their private key. These are managed wallets. This is wallet as a service. We are going to hold their wallet. We are never going to give them their private key. We are going to manage their private key for them, which is why be very sure whenever you're doing database calls, you're not fetching the private key at all and giving it to the user. And we can simply return the user wallet over here. Const user wallet equal to await get. What is this function called? Get balance. It should be get user wallet. If user wallet dot error, and what's the type here? Error string public key something. Let's do something like this. Error null and user wallet. So if there is an error, then we should return simply no Solana wallet found, As I said, realistically, this will never happen. And if there is no error, you got the user's public key, then you should, pass this public key over to the profile card. So public key equal to user wallet dot key, something like this. That looks right. The profile card will take the public key as an input. And now this specific profile card can, render the assets for this specific public key. Let's see. Public key, what are we rendering over here? Let's remove that. Account assets, what does the tip link page look like? It looks something like this. Your wallet address on the right. So let's do something like this. Div last name. Just do a primary button for now. It logs me out too often. Primary button, and I'm going to give it a copy address. This is tip link. It has a your wallet address over here. So let me do a your wallet address, and that looks decent. Clicking on this should copy the wallet address. Copied, else your wallet address, and copied, if copied, right. Let's see if this does what it's supposed to do. If you click on it, you should set copied to true. Should also copy to clipboard nextjs. All right, navigator clipboard, write text, whatever. So it looks something like this. Public key. All right, let's see if that does what it's supposed to do. Refresh. Click here, it says copied, and is my public key copied? It indeed is. Copied. Cool. So what else do we have here? Your balance, a very big balance amount here. So yeah, it's going to be tricky. It's always difficult calculating balances, but we should expose this on the backend. I think every user's balance should be an endpoint that our backend exposes. And we can do all sorts of caching on the backend, because your user shouldn't be hitting the blockchain too often. Anyways, we'll have a restricted set of tokens that the user can buy. So we anyways know what all tokens they might have. So it's very easy for us to calculate that balance on the backend. So let's create another backend endpoint that returns the balance given a public key. Yeah, I think that makes sense. So let's create a API slash balance slash, or maybe, let's call it tokens. It returns all the tokens of the user and their balance as well. Route.ts export function get next request get query cause this thing equal to request. All right, let's see if that does it. When you can't find something in the latest version of Next.js, just go to your old code and try to find a place where you view. There you go. Your old code is better than Next.js talks from time to time. All right. Address. Now that you have the address, you need to find all the tokens that this specific user uses. So let me give a brief of what I'm doing right now. When the user comes to the website right now, they see something like this. We need to show them their US dollar balance and all the tokens that they own. Don't worry about NFTs, don't worry about activity right now. Just the tokens that they own. That it could include Solana, USDC, USDT. Let's say these are the three tokens that we support right now. Sol, USDC, USDT. So the user needs to see all of these here. So I'm writing a backend endpoint where you can send an address. For example, my wallet address is this 75WW. You can send an address there. It'll return you all of your tokens and all of your balances. In our case, we have a hard-coded list of tokens. So let me inside lib add another constants.ts export const token underscore mints, or like supported underscore tokens equal to let's say name USDC mint, the address of the USDC contract, not the USDC contract, the USDC mint. Slightly different from how this is done on Solana and Ethereum. USDC Solana mint address. All right. And USDT Solana mint address is owner token program. That looks right. All right, these are the two tokens we support. We need to find this user's balance for this specific token. I think this is what is a little hard. You need to create their ATA PDAs and find their balances. Harkirat, ATA and PDA. Yeah, ATA, which stands for associated token. I mean, there's probably an easier way to do this as well. PDA, that stands for public display, never mind, program derived address. Harkirat, I don't understand either of these. You should go to a video of mine on YouTube where I explain this. Harkirat Solana tutorial. This one, that's the one. Try going through this video. It'll take you through what the ATAs are towards the end. This is like a very nice explanation using a Modi example about what ATAs are. All right. Solana find token address balance. I think there's an easy way to do it. I might have just done this in the past. Let's see, Postman. There you go. That's what we need. But there's a high probability I've already done this. Like recently when I was creating something. So Solana. Let's see what requests we have sent. Get multiple accounts. Okay, let's see, what does this return you? Must be authenticated. Get token accounts by owner. We don't need this because we know there are only 2 token accounts the user can have. But it basically means somewhere here only I will find the request that returns you the user's balance, or we can just follow this as well. Let's see. Yeah, we can probably use this the token program npm, like JavaScript SDK. Let's see. Fine. Get token balance, connection, token account. So the problem is we don't know the token account. We only know the mint. We will have to find the token account, which let's see. Await get account connection token account number info dot amount get mint connection info dot mint. So we know this. We know the mint. We know the user's address. We'll have to figure out their token account first before this function assumes you know the user's token account, which we don't. Other methods more verbose, but I'm sure this library lets you. The Solana /SPL token library lets you do it. So let me give a brief. We'll discuss more of this in the cohort. There are two types of tokens that exist on most blockchain. The native token, which in case of Solana is Sol, and every other token other than Sol. Similarly on Ethereum, ETH is the native token. Everything else is just a contract. So Solana, thankfully, these tokens are called SPL tokens, and thankfully they have this library that lets you interact with the SPL token contract. This will export some functions that will under the hood still send out RPC requests, similar to what I was sending out here. But it'll just abstract out all of this for me. I just have to do a bunch of function calls that will return me the user's balance of, let's say, USDC, USDT, or Solana. All right. If you did not understand that, that's fine. Just look at a few function calls here, and it might be a little better. But at the same time, I don't know. I have never explored the @Solana /SPL token library, so I don't know what it exports. Let's see. What we want is probably create account, close account, get or create associated token account. We don't want this. We simply want to get associated token account. Get. See what this guy does. Get us. There is a get account function, which takes address, commitment, program ID. Is there a get associated token account function here? Get. No. Let's see. Go here. Get. There you go. There is a function. Get associated token address. So you have the address const. Can you send this in bulk? You probably cannot. So const balance is equal to await promise dot all get account balance. Iterate over all the supported tokens that we have. So supported tokens dot map token function get account balance balance token where this has a name and a mint, and the user's address, which will, let's say, be a string. Token and the user's address, which was all right. That looks fine. Oh, sorry. Supported tokens.map token comma address. This needs to be a string. And here is where I will call get const ATA equal to await get associated token address. If you don't understand this part, it's fine. Go through that video. It explains it in fairly detail of how tokens are stored on chain on Solana. All right, what do you take? You take the mint, the owner. Yeah, that should do it. So new public key or I don't know, public key dot from new public key token dot mint new public key address. Let me close this. Cool. That's the associated token address. Allow owner of curve program ID, associated token program ID. That all looks right. Fine program. Yep, that looks good. Now that you have the ATA, you'll do a const. What was that function again? No, it was the get account function that comes from Solana/SPL account equal to await get account ATA. What does this guy return? It returns you a public key. What does this guy take? It takes connection and then the address already. So what you have to do now is create a global connection object. You can probably create it in constants because we'll be needing it throughout. Const connection equal to new connection, and the address would be Solana main net address RPC. There is a public endpoint that we can use for now. Mainnet dash beta. That should do it. Alrighty. So account equal to this thing, comma connection, comma ATA. That looks great. Return. So now you need the user's balance. You can assume that USDT price is 1, even though that's a bad assumption. Let's not assume that. CoinGecko pricing API. Let's see. Yep, that's a lot of money. Solana pricing API, or I don't know, blockchain pricing API. Let's see. $0 a month gives you these many credits. That is fine. Does it give you the pricing though? What exactly does this give you? Use cases, crypto wallet, $100 crypto exchange. What is that? Jupyter APIs price. Not the swap API, we need the price API. Basic swap API, flash API, game dev. Token list. Let's see what happens when we go here. Does it give us the price? It gives us the daily volume. Why does it not give us the price? Get tradable tokens only. Does this guy give us the price? That's a big list. Yeah, that's taking a really long time. Probably because everyone has Jupyter, like radium markets which propagate to Jupyter, I would assume. So what I'm looking for is something that gives me, so the user needs to see their user balances, right? They need to see something like $3, $5. If they have 3 USDT over here, so I need to find the current price of USDT, USDC, and Sol, based on which I can, show them their total balance over here. So there are various API providers that give you this. I'm trying to find an API provider that would just return me the price of a specific token. Which I can't find. Price API, there you go. That's exactly what I was looking for. There you go. All right, this returns you the price as 176. So we should cache this. I can just we should cache this. I'm not caching this right. We should cache this. Yeah. Function get price. should create a singleton class ideally. Actually, you know what? Let's go here. Supported tokens is fine. Export function get supported tokens. This needs to return the price of the token as well. So what we're going to do here is tokens. $60 into 1,000. If last updated, either not last updated or in this case we would refresh the price of all three IDs equal to Sol UTC. There we go. Const price is equal to await Axios or get. It's very ugly what I'm doing here. I should fix this. Okay, so I'll get this thing. This is to price is equal to data that will have Sol, USDC, USDT, else don't do anything. Last underscore updated equal to new date. All right, and now return supported tokens dot map s yes is fine. What is this EP? That is what USDC is. Okay. All right, and for Sol we can make it this. Alrighty. Price would be, let's see, Sol capital, USDC capital, and USDT capital. So that looks right. Prices of S dot symbol or name is fine. There you go. All right, cool. So this will now change to equal to why does it say void? That looks right. Connection dot get balance. Alrighty. We don't need decimals. I don't know what happened there. All right, there you go. We need the mint details as well. Go to await get mint. And the actual balance that the user has is this thing, right? 10 to the power mint dot decibels. That is right. And this also needs to be divided by. Right, it's this thing, and what you return to the user here is rest dot return next. That looks good to me. All right, whew, not long that took. We've created an endpoint that will hopefully return us the details of a user's tokens when it comes to, one of these 3 tokens that we're supporting right now. That includes USDC, USDT, and Sol. Let's see if that works as expected or not. If I run npm run dev and try to go to Postman and try to hit localhost :3000 / API / tokens $address equal to, let's say, a public address of mine that does have some Sol, some USDC. Let's see if it returns the right value or not. This guy has some USDC and some Sol. Let's copy the address one more time. And dead. The catch-all must be the last part of a URL. I did it for each. Okay, that happened quicker than I was hoping for. Most probably this function is failing. Let's give them a default price, shall we? Let's try that one more time. And still we get some error. What is this? Okay, nothing too out of the ordinary here. Catch-all must be the last part of the URL. Oh, where did I create this? Okay, I created this in the wrong place. Needs to be here. Move. There you go. All right. Let's try that one more time. Bunch of errors. Non-base 58 character. Oh, my bad. I'm giving a slash over here. Let's try that one more time. Get account balance request failed. Get mint request failed. Token account not found. Token account not found. Let's see. Token not mint. What were our token mints? Oh, okay. Well, we're not doing it for Solana, so has to be USDT then, I would assume. That's problematic. Now that looks right. Token account not found error. Oh, okay, makes sense. Probably. Let's see which one of these is failing. If this fails, so if either of these fail, what you can do is return 0 because the user literally doesn't have that token in their account. So it makes sense. Most probably this was failing. I don't think this was failing though, based on the log, but we'll see. Refresh. Now what's the fault? 4 to 9. Whenever you see this error, it means you're sending too many requests to the mainnet Solana, so you need another RPC URL, which we can get from one of many RPC providers. Let's see if I have one handy. Alrighty, I might have an app for Solana. It works. Mainnet. Let's replace this with a different Solana URL. And let's try this one more time. Let's see. Okay, pretty print please. USDC I have 15.25. that is indeed as many USDC I have over here. Solana I have 175. that's the price. How much do I have though? What is my balance? It says 0, even though I have 1.17 Sol, and USDT I indeed have 0. So this is incorrect. Also, now that looks right. Connection.get balance of this address. Why would it return 0? Fetch the balance of the specific public key, which is this guy right here, which does have some Solana, right? 1.17 Solana. Let's see. Is native not set to true for my guy? It isn't. That's my bad. I forgot to set native to true. That was the whole point of introducing native over here. Now if I refresh, my Sol balance is correct. 1.77 Sol I have. My USDC balance is correct. 15.25 USDC I have. The price of this guy is 1. The price of this guy is 175. So my balance, my USD balance can be calculated by multiplying these two. I should actually just add it from the backend only. So this thing and USD balance is going to be balance of index into token dot price. All right. Refresh, and now I should have a USD balance which is null for the first guy, null for the second guy, null for the third guy. Number of token dot price, token dot price dot price. All right. Prices of s dot name dot price. That's my bad. Refresh. And now you will see USD balance is 0, USD balance is 15, USD balance is 206. If you add both of these, the total balance of this user is 221. Let's return that as well. Return the tokens is this thing, and then cost tokens equal to this thing, and total balance is nothing but tokens dot, oh boy, how do you write this? I totally forgot. Reduce accumulator comma val, accumulator plus val comma 0. I think that is right. Oh, accumulator dot val dot USD balance. All right. If you don't understand this, ChatGPT, this is just an easy way to convert an array into a single number. You're reducing an array into a number. Specifically, the thing that we want to do is aggregate over the USD balances of the user, so we get their total balance. Now, if I refresh this, I see a bunch of tokens. I also see the user's total balance, very similar to what I see over Here I see a total balance. I see all the tokens that the user has. Now I have to just show this on the UI over wait for it. Here I have the wallet address. I just need to hit that backend endpoint, get the user's balance over here, get the token list over here. Good to go. Straightforward, simple stuff. One more thing I would probably want to do is add the images to these tokens. So string image, the image for USDC can be found on Google. Copy image address. That is bad. Copy image address. That is also bad. I'm trying to find a URL rather than a base 64 encoded image. That looks right. Cool. That is the image for USDC. The image for USDT is nothing but this. So let's do that. Copy image address. And the image for Sol is nothing but this. Of course, Sol. Why does Sol image give me a bunch of sun? I have no idea. And that looks right. That's fine. All right. Cool. Now let's go to the front end, specifically in what is it called, profile card, and here we will go to the account assets. This thing, we should create a hook called function use balance. Probably put this in a hooks folder somewhere. Use tokens.ts. Let's go to constants.ts and this type, let's call it export interface token details. All right, and what we're going to do here is interface token with balance equal to extends token details, and it has a balance of a string and a USD balance of a string. Saying total balance, what's it called? Where did it go? Total balance, yeah, number, and tokens will be token balance array equal to use state null const shouldn't be called tokens, but it's fine, I guess, because tokens.tokens हो जाएगा फिर. Token balances. Whatever, fetch / API / tokens question mark address equal to Alright, I've created a new hook called use tokens that returns, everything the backend was creating for us. It returns a key called loading, which means we're still fetching the data from the backend. A key called token balances, which, as the name suggests, returns you all the balances for individual tokens. These are the types for token balances. It will have your global balance as well as individual token balances. All I have to do now is just use this hook in our front end in the profile card somewhere here. Token balances, comma, loading is equal to use tokens public key. And again, if there's a loader, then you should ideally, show some sort of a skeleton. And if there isn't, then you show the user their assets. So firstly, you show them their total balance. So token balances dot total balance is what comes here. And then you render all of their, tokens over here. So let me just do something like this for now. Token balances dot tokens. Alrighty. Moment of truth. Let's see how this looks. It says account assets 0. Why is that? Oh, because this address indeed has 0 rupees. Let me update the backend a bit. Hard code my public key in the backend for now. Just so we can see some real, balances on the front end and then go from there. So my, oh boy, which account am I logged in with? Which account was I logged in with? I can just update all three. Yes, Soul wallet, update this, update this, update this. Save these. Alrighty. Now let's try that one more time. What I'm doing is just hard coding the database public keys so that I have a public key that has some money in it already. So that when the user comes here, they actually see some balance. Still says 0, interestingly. USD balance 0, USD balance 0. Copy your wallet address, 9BRT, that looks wrong. It should be 8F something something. What did I do? Soul wallet 8F, public key looks right. What am I missing? Go to dashboard. (9BRT). Where is this coming from? Oh, I forgot to update one of them. That's my bad. Save changes. All right, let's try that one more time. If I refresh, it shows me I have $221. This needs to be very big. So somewhere in our assets, I need to increase the size over here. Text dash 2XL, font dash bold. That looks decent. Let's put a dollar in front and let's just do a 2 fixed of 2. Text dash black. Make it a little bit bigger. All right. let's compare it to this guy right here. Wow, it's much bigger. So that is fine. Oh, it's Daisy. Font dash slate dash 500 text dash, I don't know, 2XL. Let's see. It's at the bottom. Flex call justify end pb dash 4 1 and make it a little more bolder. So font dash bold and a little bit bigger. Alright, that looks decentish. This guy, the text is like big. Alright, that looks okay-ish. The whole thing needs to have some PB. Sorry, PT-2. Alright, we need to show the tokens for the user over here. Log out. Login. gmail.com. Alright, something like this. Image, name, price, and then this thing. So create a table like this, should be straightforward. Let's create a component called token table. I hope you understand what's done, what's left. We've built the upper part of this tippling thingy. We need to create, of course, these buttons and this token list. I'm first creating this token list, and then I'll eventually, show what all 4 of these buttons are supposed to do in our case. All right. Token list. Let's create a component called token list. Which takes all the tokens as input, which we already have the type for. Token with balance, so something like this looks good. And now you will have to iterate over all these tokens. Dot map token, and then just token row, token equal to t. Function token row. Return div. Let's see, what does this look like? Class name equal to flex justify between. First we'll have image token dot image, class name equal to w-10 h-10 rounded full, and then we will also need the details of the token. That includes token dot name followed by 1 token.name equal to token.usd, not USD balance, dot price. Yeah, looks right. All right, we have the name of the token. Only thing is this guy needs to be font dash bold, and this guy needs to be font dash, slim. And on the other side, we'll have the users total balance. So this will be again a div, very similar to this one. Which will first have token dot USD balance, and then have token dot balance. I think that should do it. Let's see how that looks. Rather than having a full JSON.stringify of tokens over here, I'm going to do something like this. Token list tokens equal to token balances dot tokens. All right. Looks decentish. H-10 W-10. Okay, the Solana image needs to be replaced. All of them need to be fixed a bit, but that's fine. PR-2 MR-2. This is what it looks like. This is what this looks like. B background dash slate dash 100 200 background color it's BG dash whatever. All right. The whole thing needs to be that, which means the padding needs to come at various individual levels, which means the very big padding, which is over here, needs to be done individually on the assets. Can't even be done like this. That looks fine. I just had a margin, right? Yeah, should do it. Nope, that won't do it. This is fine. Not fine. That looks good. All right. We have this thing. One thing we should do is change the balances to only show, 2 decimal places. So not 2 fixed 2. Actually, it should happen on the back end only. If you open the specific route, everything should be, down to 2 decimal places, nothing more than that. Total balance as well as, each one of these. All right, let's see. Not a function. Total balance. Actually, don't need this anymore. All right. Cool. Some things have broken, but overall looks decent. This guy needs to be floating to the right. Alrighty, the same thing here. Cool. The padding here is messed up a bit. Let's see, account assets MX. PX. What is this? Oh, BR. Okay, so where is that BR? Oh, okay. All right. Alrighty. Right. Oof, you see this when you open your whatever DCEX account. Let's log out. Let's log in. Let's open a random account. Let's go to dashboard. It'll show me my asset balances. Now comes the two main things. Number one, deposit. Number two, swaps. If you remember the architecture, these two things we have sort of skipped. I'll talk through why. We need to add spots, which basically means letting the user swap, and discussing attack vectors. All right, this should be straightforward. So next up, let's add a swap section very similar to TipLink. If you go to TipLink, you will see they let you send funds. We do not allow that. An Indian exchange cannot allow you to take funds out. It allows you to add funds. We will add this functionality, but you can't add with a bank account. You can add from an external wallet address. We will add this. Withdraw, again, we can't really allow withdrawals at all right now because we don't have banking rails. Once your money is here, it stays with us forever. Of course, at some point, we should add banking rails, which will allow you to withdraw your money back to your INR account. But there are two blockers for that. Number one, getting a license so we can get banking rails, and number two, getting market makers on board that let you convert from USDT to INR and vice versa. So that's sort of a prerequisite. We'll add those sort of warnings on both of these sections. And lastly, swap is something we can build and we will be building today. All right, let's get right into it. Let's firstly add the swap functionality. That's actually the most difficult one. So we'll just have two buttons to begin with, and then go from there. All right, this is what TipLink looks like. This is what we look like right now. We need to add 4 of these tabs. Let me kick things off with a swap tab. This is going to be the most difficult one. 2 of these tabs are not valid for an Indian exchange. Specifically, send and add funds are not valid for us right now. Even withdraw isn't valid, if I'm being honest. So swap is the only one that's really relevant for us right now. So let's build this. When you click on it, you see a screen like this that lets you swap from one token to another. And we're going to power all of our liquidity again from Jupyter, very similar to these guys, or you can use a different decentralized exchange, but high level we don't have market makers right now, so we'll be sourcing our liquidity from a DEX or a decentralized exchange. All right, let's add 4 tabs over here. I'm writing all of this logic myself to create tabs. A lot of libraries let you do, give you components that let you do tabs, but I'm just writing it from scratch. The profile card, let's do it this way. Let's, the bottom half is what will be swapped via tabs, and the upper half will always remain the same. So this assets is actually going to be one of many components that renders if the user is selected a specific tab. So let's add a state over here, const tab comma set tab equal to use state. Let's call it tokens, and the tabs that exist include tokens or send or add funds, withdraw funds, and swap. Those are the 4 things that we have. So send, add funds, and swap. Yeah, it's good enough for now. We probably need 5 tabs if I'm being honest. Yeah, looks good. Tab button title equal to R. Let's add a new button component called tab button that looks similar to this guy right here. It will have states like active and inactive. Children tailwind similar to the first one. $300 and $500 maybe. That looks decent. Let's try to see what this looks like. I have to take a break, guys. This fucking monkey's making me go crazy. Right, I think the monkey is dead, guys. At least one of them is. Cool. Let's see. Tab button has been created. We need to use it over here. And active would be if tab equal to selected tab. What is the state variable called? Selected tab, comma set selected tab. Alrighty, that looks good. Yeah, and this should render if selected tab equal to tokens. Let's see how that looks. Okay, we have 5 of these, and when you click on them, a specific one becomes active. That looks decentish. This should remain cached. It starts to load again, which is not great. So invisible and visible and actually display is what we need. Visible. So it's going to be visible versus collapse, I think. Let's see. Tokens looks like this. Send, come back, send, come back. Okay, the problem is let's see how that does it. How do you hide something but not like keep the component alive? And I'm sure some of you already know. Let's see. Let's remove this. Oh, she lazy. There's something else. Display block. This visibility versus display. If you use visibility hidden, then the hidden there's no room. There's room for it. If you use display none, no longer be space on the document. So we want display to be none. We don't want to. I want to say. We don't want to mess with display. Visibility. We want to display mess with display. So display in Tailwind. Oh, there you go. Hidden versus exactly what we had. Oh, there you go. Visible and hidden. All right, let's see. There we go. Great. There we go. That looks decent. px-10. Cool. The tokens render this, and the problem is Alright, tokens, send, add funds, swap and withdraw. Tokens looks fine. Send, we can't do much. Add funds, we can actually do something when it comes to adds underscore fund. Okay, one thing I need to do now is these are not going to be tab array, they're going to be ID tab and then name string. This is where AI would have been like super helpful. I would be screaming for an AI right now. But I've been told I shouldn't code with AI when I'm teaching, which is I'm not. Withdraw name. All right. Let's focus on swap for now. Also, swap should be the last option here. Moving on. I did make swap the last. Oh, I have two swaps. Alright, what am I missing? Swap. Oh, there you go. Swap is the last option. Let's build the swap component really quickly. This is a common component you'll see, across wallets as well. If I open any wallet that I have, you will see like most wallets have this swap component where you have a base asset, a quote asset. You see the current rate, the best price. You click on review, you click on sign, and the swap happens for you. On a centralized exchange, this happens much faster. On what we're building today, DCEX, which is combination of a centralized and a decentralized exchange. It'll be slower because we're going to send this transaction on chain. Let's see how you do that. I'm going to write another component here called swap. Where do you need the public key to go? Let's send it. I don't think you need it. I'm going to define a swap.tsx export function swap return div. I've made this component many times in various companies now, so it's just muscle memory for me to build this. Let's see. All right. Let's see what the tip link UI looks like for swaps. Okay. Yeah. I hate designing this always because you need to keep refreshing quotes. As you can see, dot. Then you get a quote, and then after some times you need to refresh this quote. Did Solana drop, or are these guys' prices so bad? Oh, Solana dropped. Alrighty, let's see. Swap. Cool. Let's create a component called swap input row. Which will return basically something like this that you see here. It will be a div which will have a border, flex, and justify between. On the left side you will see a selector that lets you select one asset. Let's call it asset selector. Const base asset comma set base asset equal to use state. Base asset basically is, the first asset that you're trying to buy or sell, and then the quote asset is, what you want to buy or sell with. Quote asset comma set asset equal to, so the base asset, we can just take the supported tokens that we have, dot the 0th token over, not the 0th token over there, that's USDC. Let's flip these, let's move this to the top. The native token should be the first token over here. That looks better. Alrighty, these are the supported tokens that we have. The 0th token is the base asset, and maybe the first token, which is whatever, USDC or USDT. USDC is the first asset, is the first quote asset, and the user can of course flip them. Swap input row on select equal to set base asset as selected asset. Supported tokens looks something like this. We have a problem, Houston. Yeah, we don't want to create these on the front end. This should be in a separate file. These static tokens should be in a separate file. Let's call it tokens.ts, and token details also needs to go there. Basically, this specific file constants.ts should never be put on the front end, because we don't want to create a Solana connection on the front end. We don't want to expose this on the front end, and hence, if you need supported tokens, hard-coded tokens, whatever, ideally you should store them in a database. But since we have them here, we're making sure we store them in a separate file called tokens.ts that has no logic to connect to the blockchain, no connection logic over here. So now, wherever I was using constants.ts in a front end file, which is this one right here, this changes to tokens. This one right here, this changes to tokens. Ignore. That is fine. That's the backend already. Cool. This looks good. On select is something that you need to take as an input over here. Asset colon token details void. All right, asset selector. Selected token. Asset selector is something like this. It's like a drop down. Wow, it's like too fancy. Why are there two souls? USDC and a bunch of assets over here. We'll have to bring in another library unless Tailwind has a select. Let's see. Yeah, I don't love that. No fancy selects in Tailwind. I will have to go to another library now, which I don't want to. A library like Radix or ShatCN. I am contemplating whether or not I should do that for a V1. If you want to open a model, for sure I'll need Radix, and if you want to open, we won't have such a long token list, so we don't really need a model. But we still need a select, which I can't find a pretty one here. 5-second rule. Let's see. Should we go with Tailwind or not? No. Let's just use these selects, and we can eventually, clean this up. All right. So this looks good. Let's select. Okay, we're going to use ShadCN. I mean, it's not like 1,000 times prettier if I'm being honest, so it's fine. Asset selector will return a select which has a bunch of options. Let's hard code them for now. Class name, dark. Alright, oh god, if I was using an AI right now, it'd be much faster. Selected token dot, I would say name. Probably need an image here as well. Selected token dot image, followed by this, and class name equal to w-10, I guess. Selected token equal to, let's put one here as well. Selected token equal to base asset. Selected token alright, that looks decent. Swap needs to have 2 of these. Set quote asset. Alright, let's see what that looks like right now. If I go back to profile card, I have a swap component which is hopefully being imported from the right place. It indeed is. It's sending in a public key which you don't really need here, but sure, let's take it as an input. And let's see what that looks like. If I go to the front end and click on swap, I don't see any, oh, oopsie daisy. Tokens look like this. I see Sol, I see USDC. They're coming in the same one because the tab is going to be called swap. Now if I click on swap, I see both of these 2 rows. I need to make them closer to this guy. So let's do that. Add some padding. P-4. You pay, then this thing, then current balance. You receive, then this thing, then current balance. Shoot, this is going to be like a controlled component. Everything needs to be, shoved inside. Not really. The value here needs to come from inside. It's like going to be very hard. Asset selector on select equal to, well, on select. On change equal to, let's see what that alerts out. Swap object. So let's do a JSON e dot target dot value. Is that it? Let's see. It says CA over here. Okay, that looks good. So value is going to be, oh boy. Tokens. Supported underscore tokens. dot filter xx dot name equal to selected token dot name dot map, sorry, not equal to this thing, dot map token something like this, and this needs to be token image token dot name. Let's try that. Swap, click on Sol, it says Sol. You click on USDC, it says USDC. So it needs to basically do a on select supported tokens dot find x dot name equal to selected e dot target dot value. Okie dokie. UPCT Sol. Why does it remain constant over here? T does to USDC Sol, it remains USDC. So says USDC over here, it shows USDT over here. What the fuck? It says Sol over here, it says USDC over here. USDC. You have to select it twice for it to happen. Why is that? Let's see what happens here. Swap. Okay, I think I know what's happening. No need to filter. Okay, that might be it actually. Okay, Sol, you okay. Remove that and try it now. USDC and Sol. Still filtering. Let's remove that. USDC, USDT, USDC, USDT. Alrighty, that looks good. You need like the swap button over here. Ish. Rounded tailwind. T. Alrighty, that looks closer to what we like. We need a swap button over here that's floating. Alrighty, sorry about that. Recording stopped for a moment. The only thing I've done is added like a swap component in the middle, which is basically this button that you see right here. When you click on it, both the assets should swap. Very similar to if I click on this. It doesn't let me now because I don't have USDC, but if I did, it would just swap both the assets. Alrighty, we need an icon over here. All right, that looks decent. On click should swap base asset and quote asset. So let base asset temp equal to base asset, set base asset to quote asset, set quote asset to base asset temp. Alright, that should do it. Let's see if I refresh. This is Solana. Why is this Solana? Okay, makes sense. Option select equal to selected token dot name equal to. Let's see if that does it. That does it. If I refresh, I see Sol over here, USDC over here. If I click on it, I see USDC over here, Sol over here. So this works as expected. What else do we have here? Current balance of that specific token. Sure. We should add like a swap input row has a title and subtitle. Here, if this exists, I'll add a subtitle here. Subtitle is not required. The first one, it'll be the total balance that you have for that specific asset, which means I don't need the public key here, but I need the user's balance. So if I go back to where this is being used, which is the profile card, here we're most probably getting the token balances. Let's get him one level above. So basically something like equal to token balances and loading equal to loading. Alrighty, that looks good. The same thing needs to go to the other guy. And here the subtitle would be the balance of the specific token. So token balances dot tokens dot find x dot name equal to base asset dot name dot balance. Current balance that much and then the token. So it'll be something like this. Current balance and then see, current balance 1.18 sold. That looks right. It's just it used to be a little more subtle. Div class name equal to text slash list dash 600 slash div here, and subtitle needs to be a React node. Alrighty. Cool. Decentish. For a swap, it says you have 15 USDC. You have this much sold. That looks right. Why there's so many dollars? Remove this dollar and remove this dollar as well. All right, that looks decent. Color doesn't look right. Text dash slate dash 200 500. Size is a little bit smaller, so font dash MD SM text dash SM. That looks decent. And PL dash 2, right? Cool. UPay needs to be smaller, which means the title needs to be slightly smaller over here. Div class name equal to MD. MB-1 doesn't look too small, so maybe SM, and U pay needs to have a colon. Still is a little bigger. Font dash bold, semi bold. Looks much closer to what we want. Current balance needs to be slightly thinner. So I'm just trying to make it as close to the thing as possible. Alrighty. This guy needs to be text dash SM. Alright, let's see. Access. Current balance. Well, the size is the same, it's just thinner. So font dash thin. Semi bold. Oh, that became too much. This guy needs to be font weight tailwind and normal or medium. Cool. Current balance of 1.8. Maybe have a PR dash 2 1. All right. This looks weird. The width of this guy needs to be fixed, which means the select, just put a class name equal to W dash, I don't know, 10, 50, 40, it's too much, 30, 20, 2, 24. All right, that looks good. Cool. It's getting there. There's a little more breathing room here, so let me increase the padding all across to like 5 or 6 maybe. Looks closer to what we want. And now comes the most difficult bit, which is going to be the thing on the right, and even this thing, and then the subtitle. The reason is, this is an input box, this is like an invisible input box. You need to see some number over here by default, and you put a number that changes it. It's just historically I've built this here, and it's been a pain in the ass because it just needs to keep on changing. You need to worry about precision errors, yada yada yada. So yeah, let's do it though. We don't really have any choice. So we have this thing on the left. We have to put the thing on the right. Div, let's do a high. Okay, we see a high. Input type equal to text, and class name equal to border. We don't need any border, but take it. Padding dash 10. Let's put a border for now. Sorry, whatever. P dash 10. That's too much. P dash 6. Looks decentish. It needs to be on the right. How do you do that in an input box? I have no idea. Outline dash none. No border, no outline. It needs to look something like this. Font size needs to be really big. So text dash 2XL, 4XL. Looks decent. And it needs to start from the right. So how do you do that? Input box R12. Text align right. No. Input dir equal to R12. Alright, that's how simple. Dir equal to RTL. Why is the cursor messed up when that happens? So we can figure that out. Cool. We have this. They should have a placeholder of 0. There we go. Looks decent. 1, and then the value can change. Now we need to have, the amount, const base amount, set base amount equal to use state 0, and then the same thing for the quote amount. Swap input row. Wow, it's become complicated. We should make this slightly easier to read, I think. Still fairly complicated, but okay, I'll just leave it like this. Amount equal to base amount. For the second guy, amount is going to be quote amount. And the value over here is going to be this amount. So if I take amount as an input now, which let's say will be a string, the input needs to have the value as amount, and should initialize this to null only. And set base amount, set quote amount. Are two things that need to go down the chain. Amount equal to base amount. Alrighty. On amount change equal to value set base amount value. Alrighty. Anytime the amount changes on the input, on change equal to e on amount change of e dot target dot value. Alright, that looks decent. Any else? No, that looks fine. And anytime the base amount changes, we need to find a fresh quote for the user. So, anytime either the base asset changes or the quote asset changes or the base amount changes. If not base amount, then return. But if there is a base amount, we need to free fetch the quote amount. So we have to do a. Here is where we should use async use effects that you can cancel because you might get a stale. Also use debouncing. Alright, I'm gonna keep it like this for now. We have to write a backend endpoint that returns the code. Okay, let's see what this looks like right now. 1, 2, and refresh. Again, you can select an asset over here and you will receive a quote over here. And this should probably be disabled for the code, but that's fine. And you need a swap button then, I guess. Okay, swap button. It can just be a primary button. Right, looks decent. Probably have the same background here, which was 200. Not really. White looks decent. Alright, cool. This looks decent. So I'm going to do that. So we just now need two backend endpoints that will, number one, fetch the quote, number two, let the user swap. Basically, if you open any wallet, you put some value here, it automatically starts to fetch. It's like USDC. When you put an amount here, it'll start to fetch a quote. Quote basically means how much can you get for one sol. Here the quote came down to 171. And then when you click on the review button, something happens. So two things need to happen. Number one, as I change the quantity, the quote needs to change. And as I click on the review button, I need to actually do the swap for the user. We don't need any approval like this because, well, in our case, we have the private key of the user. We can initiate a swap for them. All right. Cool. With that, let's do it. Let's start to create two endpoints, one for fetching the quote, one for doing the actual swap. We're going to use Jupyter. Very similar to Tippling also uses Jupyter. It says powered by Jupyter over here. So same thing we are going to use. There are other dexes that you can use, depends on where you find the best liquidity. Jupyter is probably the best one if I'm being honest. Radium is another one that you can use. Let's look at the API docs. Jupyter API docs, not the price. Alright, there you go. We need the swap API. Alright, they have a library. No, they don't have a library. It's all Solana libraries here. That's fine. The wallet. Quote response. There you go. This is how you can get the quote response for a mint with some amount and some slippage. Let's see what that looks like over here. There are too many slashes. Let's get rid of the slashes. Let's see what that returns. There you go. It returns you for the input mint of Solana and the output mint of whatever this is. Let's say USDC. This is the amount that you're sending. This is the amount of SOL that you can get, or if this is for one SOL you can get 172 USDC is what this guy is returning. Are there decimals somewhere? I don't see any decimals. So we have to worry about that. So this is one SOL got converted to Lamports, or this is just this big amount. I don't know. What is the unit of this guy? I have no idea. We'll have to see. Let's see what happens when I send one. Could not find a route. most probably does include the decimals, so we have to do the same, which is fine. 1 2 3 4 5 6 how many are these? This is 8. And how much was the quantity for the other guy? This thing, which is how much decimals does USDC have? I think 6. 1 2 3 4 5 6. There you go. 17.2 is what you get. 17.2 USDC for 0.1 Sol. This looks perfect. Should probably hard code decimals in the asset list. So if I go to, you know, whatever tokens.ts, we already know the decimals for most of these things. Number, it'll be 9 for Solana, and USDC is 6, and I think USDT, I don't know actually how much USDT is. Let's see. If this is the output mint, how much are we getting? Yeah, it's the same, 6 only. Cool. So we have hard coded this. That will save us a call also in our backend endpoint. We don't have to fetch the mint details anymore. We can get it from the token itself. Decimals, number 10 to the power of decimals, which over here get account balance of token comes from supported token already has, yeah, whatever, returns the decimals in here, so we're good to go. Let's see if it broke anything in our front end. I would assume not. Yeah, that looks decent. Portfolio value dropped quite substantially. It was $223 a while back. In like an hour, it dropped by a lot. All right. Swap screen is fine. Let's write the request to fetch the quote, which, you know, as you can see, is fairly simple. I just have to send a request here with the right set of tokens. The question is, should I proxy this through our backend? Should I send it directly from the front end? Doesn't really matter. I am going to send it directly from the front end. Yeah, I'm just going to directly send it from the front end. It's fine. If you want, you can proxy it from the backend as well. So here I'm going to, in the swap.tsx, anytime this thing changes, if there is a base amount, we have to do a axios dot get. This is the endpoint we need to hit. Axios.get. Input mint would be base asset dot mint, and output mint would be quote asset dot mint, and amount would be base amount into the decimals in the base asset, and slippage 50 or like 50 bps is totally fine. NUMBER, might have to increase this on bad days, but I think for today it should be fine. Like right now the chain isn't really, it's functioning fine, so 50 bips sounds great. Dot then you'll get back some response that will look something like this only. So what we're looking for is the output amount. So set quote, quote amount to be rest.data.out amount divided by number of decimals, quote asset. The string, alrighty, that's fine. Not to string. Let's see what that looks like. If I want to sell to Solana, I get an error, most probably a course error. I get a 500 error. Oh. Quote asset.mint is incorrect. I need to add a dollar over here. That looks good. Output mint equal to quote asset, input mint equal to base asset. Let's try that one more time. Preview, payload. I did get back a 200. I did get back a out amount of 0.5 USDC. What is happening? Input mint is Solana, output mint is USDC. Amount is 18. Why is that? Amount is 18. Amount should be number of base amount into base asset dot decimals, which in case of, not into base asset dot decimals, into 10 to the power of this. And the same thing over here. All right, let's try that one more time. One sol will give me back 172 whatever USDC. If I change this to USDT, it will fetch a fresh quote for me. I should add some sort of a loader here. 2 sol will give me 345. 3 sol will give me 518. Yep, that looks decent. One thing I should do is debounce this really bad. So, or at the very least, cancel existing requests. Use effect async with cancel. This is exactly where I learned about how to cancel asynchronous tasks inside a use effect. Return, so set loading true, return async function dot then if not mounted ref dot current return null. Nah, this isn't what I'm looking for. The component is still mounted. Okay, at the very least, let me just add a loader for now. Const loader, comma, set use state false fetching quote, comma, set fetching quote equal to use state false, true, false. All right, this is bad. I would have written will sort of work, but won't really work. So yeah, we should fix that fetching quote. So first of all, this needs to be disabled if it is a quote asset. Swap input row. First one is editable. Second one, input disabled equal to true. Disabled equal to input disabled. Let's see, can I edit this now? I can't edit the niche wala, I can edit the upar wala. That is exactly what I wanted. The other thing is that I want to show loader here if it is loading. Input loading equal to fetching quote. Alrighty. Boolean, and if input is loading, input, if input is loading, then the placeholder needs to be loading basically. or the value, I guess. Input loading, then loading. That's the amount. There you go. All right, let's try this out. 2, 1. It says loading. Probably a spinner would have been a better idea, but 2, it's just loading only. 122, 5, yeah, makes sense. Cool. This is why a centralized exchange is better. You get immediate quotes in a centralized exchange. What we're doing, as you can see, it takes a lot of time for the quote to come back because it's coming from the chain versus locally. Cool, but this is fine. You have a quote. The next thing is implementing the swap function, which again I'm sure these guys will give you a way to create a transaction and sign it. Get route for a swap, quote responses thing, get the serialized transaction to perform a swap, quote if you're swap, these are the inputs that we need to send from our backend. This will return a swap transaction. Then we need to deserialize it into a version transaction. Then we need to sign it using that specific user's wallet, and then we can just send it, and if it succeeds we can let the user know swap has happened. That looks decent, fairly straightforward. Let's quickly create an endpoint where this where the user will hit when they click on what do they click on, this button right here on our website. So when they click on this button right here on our website, after they've selected some amount that they want to send to their whoever, or swap, let's say this quote came back to 345. If I click on swap, we need to actually send that swap on chain. That is what we're going to do in this specific endpoint that I'm going to create next. All right, now we need to implement this API endpoint. Let's call it swap/route.tsx, where a user will send a request to swap their Solana for something. So export function get, or maybe post in this case, the data that we expect from the user is going to be base asset mint string quote asset mint string quantity that the user is trying to sell, which let's also let that be a string for now, and the quote that the user got, because we need to make sure we give them a price that's better or equivalent to this quote that they got on the front end. Given this data, we need to now prepare a transaction, which again we're going to use Jup API. The V6 swap API, which would first fetch, we need to fetch the transaction for this specific market. So for example, the quote response here, okay, so we can just get the quote response from the user, I guess. Then quote response, which makes sense. If you have this quote response, just keep it any for now. If you have this quote response, it has all the details of what the user got on the front end, and then that you can use to that Jupyter can use to make sure you're not getting a price that's worse than the quote response that you got. So let's go back to the front end, and where were we sending the /quote request? Right here we got the response. We should store the whole response in set quote response as res. Let's keep it as null. We set it as res.data. And then we want to send this to the backend when the user clicks on the swap button. So when the user clicks on the swap button, which is this button right here, we need to trigger the swap. So we need to do a axios.post / API / what was it called, swap, and we need to send the swap response along as the data. The question is, why is it not letting me do it? Sorry, quote response. And if I go here, I get the quote response. That's what we forward there. User public key. Now this is where we need to get the user's details. So const user, or session equal to use server session, get server session, my bad, auth config, if not session.user data.user, return next response dot state json, you are not logged in, and then a status code of whatever 401. And if the user does exist, then we're going to send the we need to get the wallet for the user. So const sol wallet equal to db, which comes from dot user dot find first, or sorry, sol wallet dot find swap transaction is this. Then we deserialize the transaction and sign it using the user's private key. Oh, pretty easy. Swap transaction buffer is buffer.from swap transaction base 64. Transaction is versioned transaction, which comes from Solana / web3.js. Deserialize the transaction buffer, and then we need to sign it using the user's private key, which is going to be a challenge. Const private key equal to get private key from db, comma dot const private key uint array equal to uint 32 array, or uint 8 array actually, dot from ar uint 8 array from new uint8 array. My screen is lagging. Okay, much better. Oh. Alright, I think dot from might work as well. Alright. Const key pair equal to key pair dot from secret key private key uint8 array turn key pair. That looks right, even though my screen might be lagging a bit. So what I'm doing here is, unfortunately, what happens in the database, if you remember, already have the database running. The private key is stored like this. It's not an array, it's a string with, comma separated values. To ensure we're able to get back a key pair from this string, we, first parse this string, convert it into an array. That's what this line does. This line will convert 1, 2, 3 into an array that looks something like this. And then once we've done that, we create a uint8 array, just a JavaScript object of this, uint8 array class with these elements of the array inside, or these elements of this private key being individual elements of the uint8 array. Then the key pair that comes from solana/web3.js has a function called from secret key that lets you generate the key pair from given a private key in the form of a uint8 array. Again, this uint8 array, these numbers that you see are effectively the private key associated to this public key. So, well, not this public key. We hard coded this public key from my wallet. So we'll probably have to hard code the private key here as well. But you get the idea. This key pair is now, has enough power to sign the transaction, which is what we need to do. So this is going to be secret key. What does it take as an input? Wallet.pair. So I guess this should be enough already. Transaction.sign, and then we just need to sign the so I send the transaction, get the latest block hash, serialize the transaction, send a raw transaction and confirm it. And oopsie daisy. Await connection.confirm transaction. Here again we need to import connection from here, create the raw transaction, send it to the blockchain and await for it to confirm. Once it confirms, it will probably return you. Okay, this looks decent. The transaction ID, we can return that to the user. Return next response.json. The transaction ID. All right. This most probably will work as expected. This is actually straightforward, but let me explain this one more time. When the user clicks on the button, this button, they go to their dashboard, go to the swap section, select, let's say they want to convert one SOL into USDC. They get back a code that looks something like this. They click on the swap button. This should send a request to the backend over here. This will first get the quote response. What's the quote response? Whenever the quote was fetched over here on the front end, that gave for one SOL you can get back 171.55. Whatever response came back from Jupyter is the response that comes in this request. If I click on the swap button, you'll see that response go out. We get the user's details, make sure the user is actually logged in. We get the user's Solana wallet address from the database from here. We make sure it exists. It will always exist in our case. Then we get back a bunch of bytes from this quote api.jup.ag/vc/v6/swap. This basically returns us a transaction in a specific format that you can then basically serialize or deserialize into what's called a version transaction. This is, think of a version transaction as just a transaction. It's a new way to do transactions in Solana that was introduced like 2 years ago or so. You convert this into a transaction. You make the user sign the transaction. So the most important thing about thing that you need to do is Jupyter will give you a raw query or / transaction that says you want to swap one asset for another, but your private key needs to sign it, and only then the swap can happen. That is what happens in this line of code. The only extra thing here is I've written a function called get private key from database, because the database returns you the private key in a certain format. We need to convert it into a key pair, where a key pair is something that at solana/web3.js provides you. It's basically the same thing that we generated initially when the user signed up. We sign the transaction, we serialize the transaction, we send the transaction over to the Solana blockchain, and then we await for the transaction to confirm. Once the transaction confirms is when you're good to go. And then we return back the transaction ID to the end user. That's pretty much it. That's it in action. To be able to see it in action, we need to sign up using a fourth account, and then let me put some money in there, and then we'll go from there. So first I need to sign up using a fresh account. Let me do that. I think I've used 3 emails by now. I haven't used this 4th email. So let me use the 4th email. This should generate a private key for me. Most probably, if I go to my dashboard, I'll currently have 0 SOL as expected. Wait, why does it say 202 SOL? Okay, this is not the email I was looking for then. What is the email I haven't logged in? Oh, I've logged in with all emails, have I? Okay, let's get rid of the database. Let's delete the database completely. Let's do a fresh sign up. Delete everything. INR wallet, delete everything. User, delete everything. Let's sign up one more time on the platform, or sign in. And this time a fresh wallet will be generated for the user. If I go to my dashboard, it says 0 USD. Why is the image messed up? I'll have to look at that. It shows me I have 0 money right now to trade with, but it does give me my wallet address, so I can actually send some real SOL to my wallet address. This is something you can do in Indian exchanges as well. Indian exchanges don't prevent you from receiving money from let's say your relatives in the US. You can always receive money from relatives, from friends. You can't send money out of India. So you can always receive Solana from your friend in the US. You can't send them Solana. Okay, this transaction is successful. I've sent money from here on to, let's say, my exchange account. So if I refresh, wait for some time, hopefully I've sent it to the right address. Yeah, there you go. It says I have $17 now, which I just on-ramped. Not on-ramped, I just, sent from my other wallet over to this wallet. Then if I go to swap, and let's say I want to swap 0.01, that's my, 0.01 is fine. I want to swap 0.01, so it tells me I can receive this much USDC. Maybe let's change that to 0.02. Oh, not that, 0.0. That's why I wanted to add debouncing here. I'm sending too many requests to Jupyter right now. Alright, that looks right. For 0.02, I can get 3.4 SOL back. If I click on swap, I get back a 401, which says you are not logged in. I am sending a cookie, right? Why does it say I'm not logged in? That is the right way to get back a user's session on the server. I think so. Get server session, that looks right. Maybe, just maybe, when you're sending an Axios dot whatever post, you need to send the credentials along with it, with credentials true. Let's try that. Swap. Still I get a 401. Refresh. swap 0.1 or 0.01 is a better quote that I want to send. That looks right. Click on swap, gives me a 401. Why? I am sending a cookie. I was right there in the logs. I have not added a secret for nextauth URL. So if you go here, suddenly muscle memory also kicked in, and I realized, I've forgotten to put a JWT secret. I think it happens here in the nextauth config. At the top level, you can add a secret, or maybe somewhere in. Let's see. I have another project where I've used nextauth, so we just copy paste source app. Oh, sorry, probably has a lib as well. auth.ts. And here we search for secret, and it comes over here right above callbacks. That looks right. Oh, of course it doesn't give me types because makes sense. All right, cool. We just need to add a secret here. I think I need to re-log in. And when I do, I think we should be good to go. So let's go here. Let's sign in one more time. Totally forgot what email we had used. So let's see. It's 100xdevs@gmail.com. I sign in. I go to dashboard. I go to swap. I select 0.01. I go to network. I click on swap. Well, I'm not getting a 401. That's good. It's still pending. That's good. It means the transaction is probably going through, and I'm converting 0.01 SOL into 1.7 USDC. Backend looks fairly healthy. It's just that the blockchain takes some time for a transaction to happen, so there's nothing much we can do other than waiting over here. This is one of the reasons a CEX is slightly better than a decentralized exchange, because this swap, as you can see, is taking a long time. The good thing is you can leave and come back eventually, and you'll see your balances update. But yeah, swap can take a long time based on a bunch of factors. In this case, I don't know what that factor is. Maybe this is like too long. Most probably this transaction is not going to go through based on how long it is taking. Let's see. Let's open the dashboard in another tab and look at our token balances. I still have 0.1 SOL, which means most probably this transaction is not going to go through. Let me try that one more time. Let me convert 0.1 or 0.01 SOL into USDC. That should give me 1.9 USDC. Oh, sorry, whatever. That looks wrong. 17.1 USDC looks wrong. Swap again. 0.01. That's the thing. Since we're not debouncing, we're sending too many requests to Jupyter, which is why the quote amount is incorrect from time to time. This time it's correct. If I click on swap, we again see a request go, and we'll see if it gets accepted by a block or not. And if not, then we'll try changing the RPC. Most probably, there's some probability that there's some issues with this RPC. We have seen this before. When you're sending transactions using a Alchemy RPC, a lot of times your transactions don't get submitted. I don't know why. Go back to tokens. Yeah, nothing changed here. Okay, I'm going to change the connection object for this post request only that's sending out money. That's route.ts. The connection object here is not going to come from here, but be const connection equal to new connection, and I'm going to give it the mainnet beta Solana URL. This one right here, and let's see if that does it. I've just changed the RPC URL because I've seen this in the past that Alchemy is not the most reliable when you're sending out transactions. It's good for fetching data, but a lot of times I've seen when you're submitting transactions on the blockchain, they don't go through via Alchemy, but they might go through via this mainnet beta URL that we're using right now. And let's see if that's the case. We're going to wait for like 20 seconds. If it's supposed to happen, it'll probably happen in 20 seconds. It doesn't crash, so that's good. It means it's hopefully reaching the right places. Let's look at the code one more time. What does it do? It fetches, I don't know if it's stuck here or if it's stuck here. I would assume it's stuck here on the blockchain transaction. Let me put a log here to see if Joe returned transaction. Oh, seemed like it happened. Swap succeeded. There's a transaction hash. There you go. It was related to the RPC URL. If I go back to my tokens now, they still show this because we don't have auto refreshing. But if I refresh my page, moment of truth, I have some Solana that went down. Why did my USDC not go up? Or did I just swap it for a very weird token? No, there did not go. Where is my USDC? All right, let's see. Solscan.io. Let's look at the transaction signature. It sent me 1.7 USDC. Question is, what is this USDC? The address looks right. Let's go to my wallet address on Solscan and see what the balance is over there. So if I go to my wallet address on Solscan, I see $1.7 worth of USDC. So the transaction has happened. I also see the failed transaction over here. Could have failed because of I don't know. We have to look into this. It could have failed because of this is a system program instruction. What I was saying was because of the Jupiter, the quote failing, basically, the price moving by a lot. But it seems like that's not the case. Question is, why don't I see any USDC here? Where is my USDC balance? Why is it not 1.7? I don't know. Let's see. Let's go to the route for the tokens. And here I want to see the account balance. Let me just log the ETA and refresh. Let's see what the ETA was. We have a few of them. We'll try all three of them one by one. Let's try the first one. This probably is the right one. Does not exist. Let's try the second one. This does not exist either. We don't have an associated token account for USDC. That looks wrong. Let's debug. Copy the wallet address, paste it here. Look at the transaction. This will probably create an associated token account for me. Let's look at the logs. We'll probably have the God, it uses the address lookup table. Create account. Associated token program, create idempotent source account. There you go. DWQI something, and that looks right. DWQI. The question is, why isn't the associated token account here? DWQI. Oh, there it is. It is DWQI. DWQI JHQJ. That looks right. So why is it not getting the balance is the question. Console.log account. Let's try that. We do get an account. We do get an amount. Amount is 1.7. That looks perfect. It has an N towards the end, which I don't know what that is. Account dot amount, and then we will also log account dot amount divided by this thing. Refresh. Wait, what's decimals here? Oh, that's my bad. Token, not decimals. There you go. That's mostly my bad. When I added decimals, I forgot to do something. Or like forgot to get it from the right place. You get the idea, all right. Localhost colon 3000 / dashboard. Or this page right here. Now, if I see my USD balance is 1.7. So we're good to go. If I swap again, you know, if I want to convert back my USDC, let's say 1 USDC into Sol, it gives me a code. I can get back this much Solana for 1 USDC. If I click on swap and wait for some time, it'll hopefully be able to, you know, again do the transaction, and I will be left with 0.7 Sol and 0.7 USDC, and the rest of it would be Sol. Let's wait for it to happen. Let's also add some sort of a alert if and when it does happen. Let's see, let me quickly add that to swap.tsx. If res.transaction ID, let's put this inside a try catch. Alert error while sending a transaction. Ah, shoot, I refreshed. Shouldn't have done that. Data.transaction ID, then we'll do swap done. Cool. Refresh. Let's see if the transaction did succeed. And seems like it did not. I still have 1.71 USDC. Refresh one more time. Yeah, it looks right. Oh wait, did it change? No, it didn't change. Again, we'll try to convert 1 USDC into Sol. That's 0.0058. Let's click on swap. Let's sit back and relax and wait for, you know, the transaction to get submitted and hopefully get accepted. To wait for 20 seconds or so. If it does succeed, it'll put out an alert. Yes, it's going to be really slow, which is not good. We need to figure this out. Yeah, we need to. I'm thinking if this is, you know, this is like very bad UX, but the question is why? Most probably because our RPC is, I'm using the public RPC. That's why. Let me get a RPC from a better company, and then let's see if that makes it any faster. This again is stuck, which probably means this transaction also did not happen. That's one too many transactions that are not happening. I'm going to blame the RPC for now, but there's only so long I can blame the RPC for. So let's try Helios here. Helios RPC. Let's log in. Let's create an RP. Oh, they already have one for me. All right, let's try to replace the posts with not. Oh wait, when did this happen? Oh, sorry. That looks right. Let's try and see if that does it. Well, seems like it already happened. How much USDC do I have now? I have 0.71. So let me try converting 0.5 USDC over to Sol. That will be Sorry, wrong one. 0.5 USDC into Sol. That will be 0.0029 Sol. That looks right. Click on swap. Let's see how long it takes. On an RPC by Helios, which I assume is slightly faster. But what do I know? Have I added the alert already? I have. Oh, I don't know if this is this format in which you get back the response. Dashboard. Nothing happened yet. I probably need to change the fees that I don't know actually. What's the current TPS of Solana? That doesn't look too bad. Okay, that didn't do it. Let's try that one more time. Network, we're going to swap 0.5 USDC. That looks wrong. 0.5, that looks wrong again. 0.5, we should really fix. We're sending too many requests here. Swap. Alright, let's see. We sent a request via Helios this time. And there's nothing much we can do, but wait, that's a really long time it's taking for a swap to happen. What we can do actually to make this mildly centralized is, if the user wants to swap, we just take a swap from them, and then we can just keep retrying on our server. If the user says they want to swap X for Y, we can just keep retrying on the server. Since we already have their private key, we don't need them to sign this again and again. That might be one approach to take here. But okay, let's wait a bit. Let's look at what's happening on this account. That's the one. Okay, a bunch of them are failing. Probably because the quote expired. Oh, insufficient funds. That sounds like I sent some wrong inputs here. Yeah, that's taking a really long time. We need to increase the compute units, or there's no or. That's probably the only thing we can do. Let's see. Swap. What happens if I spam the request? Probably nothing. Question is are these guys as slow as well? Let's see. Let's open tip link, and if they're not, I just need to increase the CU limits. Maybe just do what they're doing. Let's try to swap over here. Let's convert 0.001 Sol over to USDC. That's whatever, 0.17 USDC. Let's see how long that took. It's also taking longer than I would hope for, even on tip link. Okay, so maybe it is just slow when you're using a decentralized solution. Longer than expected. Please wait, it can take up to 3 minutes. Yeah. All right, so that's not great. Oh, there you go, swap complete. Let's look at this transaction, see if they were. Set compute unit limit to be 338903. Price to be 64915. We should probably do the same. Even though that's a lot of money. 0.064 Sol. Okay, just for kicks, we should probably just allow. Is there a setting here? Swap settings. It's just for okay. The slippage and not for the compute units. All right, let me give a high level of. Oh, there you go. Error white sending transaction. That's not great. So basically, this is what is happening. The transactions that we send, for example, this is a successful transaction we sent a while back. We set the compute units to be this much and the compute price to be, slightly lesser than what these guys put. When you're on the blockchain, you're pretty much competing for, your transaction to go through amongst thousands of transactions. And you can incentivize the miners by, increasing gas on Ethereum or here compute units and, compute limits more specifically. So yeah, if we do, but the problem there is, if people are doing so many micro transactions, they might end up paying too much in gas. We need to figure out what's the best solution here. For now, this is what we have. We have the website. You can come sign up. We hold your private key for you. We let you see your wallet balances. For example, I have 0.71 USDC and some SOL. We let you swap, but the swap will only work for you on a good day, by which I mean, as you've been seeing right now, the swaps are taking a really long time, not just here, but also on TipLink. But specifically for us, a lot of them are not going through either because we're not incentivizing miners enough, which is something we can add. But that is a sensitive topic, by which I mean, you need to let the users know that upfront. So, it'll require a bunch of UI changes as well. Okay. Hey, even though you're spending this for this much, you're also giving XYZ in gas, which could be a high number based on, what your compute limits are. All right. Hopefully that's clear. If not, that's fine. We have 3 empty tabs right now. Send, you cannot do that in an Indian crypto exchange. Add funds, you can probably do that. You can add funds from your Phantom. That's exactly what I did. That's how I sent money from here to here. And withdraw also is something you cannot do in India right now. So these 3 are things that, where you can add a warning here that says, sorry, we don't support this yet. Indian regulation, yada yada, and tokens. So you can see your wallet address as well as tokens. Let me give a brief and quickly summarize the whole thing that we've built from top. All right, let me summarize what we've built. We've built a website where you can come and sign up. As soon as you sign up, we generate a wallet for you. It's called wallet as a service for a reason. It's basically you not having to maintain a wallet and someone else maintaining it for you. In this case, this platform. If you come to the platform, you can see your publicly available Solana wallet address and you can track that wallet over here on the blockchain. So this isn't necessarily the only front end for your account. You can also go to SoulScan. You can go to a different explorer and look at what all you actually hold. The only thing is the private key is held by us. Everything else is, it's a publicly available address. You can always prove, okay, whatever balance we're showing you over here is indeed the balance you have. You have $16.03 and $0.7 in USDC. So like $16.73. That's the same thing that we show you here on the account as well. There's very clear proof of reserves. Other than that, everything else here is blocked for no reason other than the fact you can't really withdraw funds or send your funds to anyone if you're an Indian crypto exchange. Whoever wants to put money here either can put it via INR or can on-ramp / bring money from a different wallet. They can't really send that money out of the CEX ecosystem or the whatever WazirX ecosystem, the coin DCEX ecosystem. Finally, we have a way to swap. We have some selected tokens for now, USDC, USDT, SOL, and you can swap between them. This transaction goes on the blockchain. For example, the USDC that you see over here I got this USDC through a bunch of transactions that happened directly on the blockchain. There are upsides and downsides to this. The upside is, as I said, proof of reserves is the easiest one. There's a wallet for you that's available. If there's ever a hack, hopefully, the attacker is not able to train everything because everything is not present in a single wallet. Everything is present in distributed wallets. The downside is since every transaction is happening on the blockchain, every transaction requires a gas fee. Every transaction requires you to, have some SOL in your wallet. If you don't, you won't be able to pay for gas. Every transaction is slow. So that's the downside of, getting liquidity from a decentralized exchange. But what's the upside? The upside is I don't need any market makers. My platform is up and running. I can deploy this and, we're good to go. Of course, there are a lot of security concerns there, so you shouldn't deploy this. I'm not deploying this as such. We should make this better before deploying. But even if you do deploy it, the good thing is you don't need market makers. You can use automated market makers. You can use something like Jupiter. But the downside is transactions will be slow, and a trader wouldn't come on this platform. Retail might. Simple user who wants to buy from time to time might come and buy a few Solana, buy a few Ethereum. A trader who needs to do high frequency trading is not going to come on your platform, and a lot of times majority of your volumes comes from there. So it depends on who you're targeting with this specific platform. Is it retail? In that case, it's fine. If it's traders, you're probably not going to make a lot of money because traders are not going to come and trade on this platform. Cool. That's a recap of what we have built. If you remember from the beginning, there is another approach, a slightly better approach that not slightly, like significantly better approach that you should use, which involves multisigs. I don't think I have the time to code this right now. It's already probably a really long video. But let me take you through the architecture at the very least to share how you should do this in case you actually want to deploy this. Don't deploy this as such. If your database is attacked, all of your user funds are gone. Doesn't matter if they're in individual wallets, all of your private keys are gone, and then users can pull, or the hacker can pull funds from it. So yeah, I would strongly urge you to not deploy this anywhere, or not even share this as an architecture anywhere. This is the better architecture. Let's go through this next, and then if we have the time, maybe code it. If not in this video, then maybe in a different one. All right, let me take you through the better architecture. I hope you already understand why this approach is really bad. I've already deployed this on wallet.100xdevs.com. And the problem is anyone that comes here and signs up, right, their private key is going to be stored in a database in neon.tech. So if I open, neon.tech, which is my database provider, and I go to the specific wallet over here, I can run an SQL query that looks something like this. Or, the folks at Neon can run an SQL query that looks something like this, Soul wallet, and get all the private keys if they run whatever the right, table is over here. It's highly centralized. Some bad actor can pull out all the private keys and then pull out all the funds, which is why this approach, even though it's easier to implement, and believe it or not, a lot of platforms similar to Bonkbot actually use this approach. At best, they just encrypt the private key that's being stored in the database. Other than that, they literally have all your private keys in a single database, which is very scary, which is why we had the other approach that usually most exchanges use. Even DCEX used some sort of an approach similar to this. WazirX. We'll understand what this approach is. We'll probably not be implementing it, but a lot of this will be discussed in the cohort as well when we'll be building an exchange or a gambling website in the cohort. We'll need to build or hold user funds. We'll need a custodial system, and hence we'll be building it the right way in the cohort. But let me share the architecture. The architecture high level looks something like this. Whenever you're building an exchange, right, you will try your best to make sure all the private keys are not stored in a single place. So ideally, what should be happening is when a user does sign up on your platform, let's say they send you a request to /signup, their private key right now is being stored in a database. That is the approach that we took right now. Okay, when they sign up, we store their private key in the database. As I said, that's the wrong approach. So what's the better approach? The better approach is we create a multi-sig for them. Let's say this is one approach. There are many approaches, but let's say we have 3 servers running: server 1, server 2, server 3. All 3 of them are running on different cloud providers: AWS, GCP, DigitalOcean. And hence, if AWS ever gets hacked, or there is a notorious engineer in AWS that's getting into our systems, he alone will not be able to sign anything or pull out any funds. This has a private key 1. Let's say this has a private key 2, and this has a private key 3. Now, anytime a user comes or signs up, we should create a multi-sig for them. We should not create a simple wallet. We should actually create what's called, a vault in multi-sig terms, but basically a fresh multi-sig for them. And the signers of this multi-sig should be all 3 of these private keys. That way, the user doesn't have the user still has a single account, but no single signature is enough to pull out funds from this, or even swap. If the user wants to swap, then also you might require 2 out of the 3 of these signatures based on what kind of a multi-sig this is. If this is a 2x3 multi-sig, which means there are 3 public keys associated to this vault, 3 signers, at least 2 of them need to sign, and only then will every transaction that the user wants, including pulling the funds out, swapping, or anything else, will actually be approved on the blockchain. And hence, this is one approach that's slightly better, not slightly, significantly better than what we had done, which is when the user signs up, rather than creating a simple wallet for them, we create a vault for them. How can you create a vault? It's depends on, if you want to write your own multi-sig or use an open implementation. For example, Squads is the most, this is the one that I was going to use to implement. Squads is the most popular multi-sig on Solana, But the problem is Squads has a one-time fee of around $10, 0.05 soul, something like that, when you create a squad. So basically, effectively, what we want to do is create a new multisig for them. Let's say, user_1. I'm doing this through a UI. You can also do this using a CLI. When a user comes to your platform and they sign up, we want to do something similar to what's happening on this UI, which is we create a multisig for them, which has 3 signers, member 1, member 2, and member 3. The only problem is, as I said, as you create this multisig, let me, quickly put 2 more members here and show you. Add member. Let's just have 2 members for. Okay, how can I ether soul scan? This is member number 2. If I click on next, the problem is they have a deploy fee of 0.05, or this 0.05 one-time fee, which is really high, because then every user that's coming on our platform will have to pay $10 for it. So if you use an open implementation that is well tested, well audited, then of course you'll have to pay them, and it becomes an expensive approach in that case. If you have your own multisig, if you deploy the squad protocol contracts yourself, I don't know if you can. I mean, you'll have to look at their licensing. I'm sure their contracts are open source, but at the same time, I don't think you can just deploy them willy-nilly. You'll have to. The licenses might be tricky, and you can't just deploy their contracts and use them. I think I could be wrong. If you can, then great, you're good to go. If not, then you'll have to pay either $10 per squad that you're creating, which is a lot of fees. If you have 1 million users, that's $10 million you have to pay. That's not great. You can charge the user for this, but you get the idea. You need to find a better, easier, simpler multi-sig implementation that's not paid, or you need to do a business deal with these guys. Okay, we'll have a lot of users, let us pay a one-time fee. All right. Cool. That is how you build a slightly better approach, or like a slightly better exchange which has multisigs. This again is a wallet as a service. This isn't a traditional centralized exchange that's pulling funds into a parent wallet. This is again, every user gets their own wallet. Only thing is, every transaction that they want to sign gets signed by 3 different signers in our case. There still are a lot of attack vectors here. I had a whole section around attack vectors both here and here. I'm hoping it's very easy to understand the attack vectors in the simpler approach. I can just, any engineer from Neon console, this website neon.tech, can go into the database, get the private key, and pull the funds out. You cannot catch, this is highly anonymized. So you will not know which engineer this is. You will not be able to tell if this is an engineer's attack, if this was neon.tech, if this was me who, let's say I lost credentials, like password to my this email, then it could just be my fault. So it's very hard to tell the source of attack, and hence there are a lot of attack vectors, at least in this first approach. In the second approach, even though it might feel there aren't any attack vectors, there still are. For example, what if an engineer in the team, in the specific team, this is a simple backend, right? We don't have multiple backends. This is a simple Web 2 backend where the user signs up, where the user sends a /swap request or a /transfer request, right? When the user sends these requests, what if one of the engineers in this exchange is notorious and sends a request on behalf of a user? What if they send a request to /swap on behalf of a user, considering they have access to the backend? That swap request will eventually reach each one of these private keys, and they'll end up signing it. Which is why, even though it feels like we're decentralized now, we still have a centralized system over here, which an engineer in the company can sign in and swap from. How do you fix this? These are the challenges you have to think about when you're building something like this. And the answer here is you have to add end-to-end encryption between the browser and the signers over here. So whenever a signer receives a request to sign something, it needs to check that it indeed came from a user and did not come from a backend, that it wasn't malformed in the backend. When the user can send the request to transfer, the backend can also change it to be transferred to a different address, right? And hence the vault, or each one of these signers need to somehow ensure that this request came from here, which means there needs to be end-to-end encryption between this guy and this guy. That is how you prevent this attack vector. There are still a bunch of things you need to think about. This will also be very slow. If every transaction that comes, a swap transaction, goes to 3 signers to sign, first you have to create a transaction request here from the vault, then this guy will sign it, then this guy will sign it, then you have to approve a 4th request. Basically a single transaction becomes 4 transactions if you're using a multi-sig. Already we saw swaps were so slow on our platform. If you have to do 4 requests, then it will be slower. So these are the challenges you have to think about. I'm still figuring this out. I mean, I'm trying my best to get an FIU. If we do get one, then we'll try to understand if this indeed even is an approach we can take. And if not, then we'll have to just build it the way every centralized exchange builds it, but with a more secure primary wallet. Cool. That's all the jargon I had for this one. I will see you guys in the next one. I'll see a few of you in the cohort. Bye bye.